Yeah. Good morning. Can you guys hear me?
Yep.
Okay. So yeah, this kind of came out of our Amador Calaveras consensus group, the ACCG, which I think some of you are familiar with. And it's a group of agencies, industry, environmental groups, and interested citizens working together toward common goals within a defined area of interest and adjacent to it. And then part of that group was the monitoring group, which we were a part of. And we started to put this together, what, Becky, 2, maybe 3 years ago. And it's kind of morphed over time. Started out to basically report out on the power fire studies and monitoring we had done for the ACCG, and related to the post-fire topic we're discussing here. The idea was to take some of that information and use it to for project planning in the power fire at the time we were implementing, as well as moving forward. And then we've also linked up now with SOFAR on this, because they've got the big Caldor Fire next to us, and we're hoping that some of this information will also help inform how we move forward in that project. So we see this webinar and field trip that's associated tomorrow into the power fire as kind of a first step of maybe a 2 or more step kind of process, with something coming up in the fall on the SOFAR side in the Caldor, to kind of take that next step. And I will pass it on to Sue to correct all the stuff I just screwed up.
Sounds good. All sounds good. Sue Britting with Sierra Forest Legacy. So my organization participates in both collaboratives, the ACCG and the SOFAR collaborative. And when we were struck with the Caldor Fire last year, it seemed like it was a good time to try to bring these two collaboratives together, because the Caldor Fire covers both a little bit of ACCG and a good chunk of SOFAR. And so an opportunity for the collaboratives to work together collaboratively, take a look at, for us in SOFAR, to take a look at some of the great work that you all have been doing to monitor post-fire responses, and then really think deeply about what should we do in the Caldor footprint? What are the approaches that are most successful and have good results? And so that's what this is all about, trying to really gather up lessons learned and relevant information, and then think about what approaches to take in Caldor. And as Chuck mentioned, there's a plan for a follow-up tour information exchange in the fall, hopefully in October. So welcome, and thanks for everyone attending.
All right, thank you so much for that introduction. Since I've already introduced myself, I'll just a couple of logistics from my standpoint. So I'm going to be essentially introducing the speakers today and trying to keep us on schedule with Stacy's help, of course. I'll also be running the panel discussions. So we have 2 panels scheduled, one for the morning and one for the afternoon. During these panel discussions, it will be an opportunity to ask any questions that didn't get answered during the presentations. If we have some time after each of the talks for questions, we'll take a few. If not, please put them in the Q&A or hold them close to your heart so that you can ask them again in the panel discussion. We'll also be just chatting with the panelists on a variety of questions that I think we all have concerning post-fire restoration. And I'll just reiterate, I think, being a member of both the ACCG and SOFAR, and really focused on the monitoring piece, I really felt like this was an opportunity for us to think about the monitoring and the research that we've done, both in the power fire and beyond, focused on post-fire restoration, and really think about how we can apply that to the Caldor Fire, and not just the Caldor Fire, I think any fire footprint within the Sierra Nevada. And so I just want to keep that, have everybody keep that in the back of your mind, and thinking a little bit about how what we learned today can help us think about and plan for restoration efforts in other fire areas. Okay, so the first set of talks today will be focused mostly on vegetation management and prescribed fire in post-fire landscapes. We'll have a break in the morning, so everybody can stretch their legs, get a drink of water, all that good stuff. And then, like I mentioned, we'll have a panel discussion at the end of the morning. I think that this first set of talks really, sets the stage for the afternoon. We're really talking about habitat, vegetation, and what we need to think about in these post-fire landscapes as far as creating either the conditions, the desired conditions we want to see in them 10, 20 years later down the line, but also how this sets us up for habitat for particular wildlife species, not just in the early cereal conditions, but also thinking about those late cereal species and how we might plan in post-fire landscapes to accommodate for them as well. Okay, so our first speaker for today is Martin Ritchie, and he's with the Pacific Southwest Research Station, and he'll be speaking about management of oaks in post-fire landscapes. So now I'm going to pass it over to Martin to share his presentation.
Okay, thank you. Can you hear me okay?
Yes, we can hear you.
Okay, let's see if I can effectively start this thing. I'm having trouble getting my mouse where I need it to be. Okay, that's good. All right, let's see if the slideshow will start. So I'm going to be talking about managing black oak post-fire, and specifically this little study that we did tries to address the question: can we accelerate tree form development? You have a fire comes through, your oaks are top killed, they sprout back, and so now you've got these sprouts. Can we do anything with these to accelerate getting them back to something like the tree that we had there before? So my colleagues on this are Ethan Hammett, John Pascal Barrow at Cal Poly, and Humboldt, and Jonathan Long. Let's see if, oh good, the slide advanced. Just a brief intro on black oak. Probably don't need to give you guys this, but so it's a deciduous hardwood, widely distributed in California and numerous different forest types, common associate of ponderosa pine and others, especially in the mixed conifer zone. It's shade intolerant, so conifer encroachment is often a concern, although maybe less so after a high severity wildfire, or at least in the immediate aftermath. And an important consideration here, at least in the context of my talk, I think, is that there's no commercial market aside from niche usage in firewood right now. That wasn't always the case. 40 years ago, we had local mills producing hardwood. I used locally sourced hardwood for woodworking projects back in the 70s. And because we had mills in Trinity County and Butte County, and you could get this stuff, but it's not the case anymore. That's not to say that black oak doesn't have value. It just doesn't have any commercial value in California right now at any scale. So the values are harder to determine. You can't really necessarily put a dollar sign in front of it. Can I get rid of that there? Okay. A word about black oak and fire. I'm always reminded when I think about this quirky little scene in The Wizard of Oz where the coroner has to explain to the mayor that when a house lands on a witch, you kind of got to be careful and check because they're not necessarily dead yet. Now, of course, the house landed on me. I'd certainly be dead, but with witches, they're special. And they might only be merely dead as opposed to most sincerely dead. And black oak's kind of like that. You can have a high severity wildfire, but the black oak, of course, is most of the time only merely dead. It'll sprout right back readily because of these latent buds around the base of the tree. And they thrive because they have an intact, well-established root system. And of course, most of their competing conifers are often dead. So so there you go. You have this this kind of head start on a future oak tree. And the sprouts will self-thin over time, although it's a very long process. McDonald in '69 said that it was a 30-year process. I'm not quite sure where he gets that, but if it is 30 years, it's plus or minus. So there's wide variation on either side of this. This is a 30-year-old fire. This is the fountain fire, and I took this photograph just before the bud break this spring, and those are some oak sprouts that are around 20 feet tall now after 30 years. but they certainly haven't started self-thinning much. There's still 6, 8, 12 stems per oak out there in many places in the fountain fire. You can occasionally find one out there that has self-thinned back to 1 or 2 stems, but they're pretty rare. Okay, so here's the question. Can we reduce the number of stems more quickly so that we can accelerate growth to fewer stems and to maintain fewer stems so that at some point we transition from this little shrubby looking thing into a small tree, and then maybe down the line a bigger tree but we get there quicker. So there's 2 parts to this, and I'll try to answer both parts, hopefully successfully. So the study methods on this are really simple. We go into a fire, we find a cluster of oak sprouts on maybe an acre, and we treat some of those. So we randomly treat some of them with thinning back to just 1 stem, and it would be the largest stem, best looking stem that we can find. Some of them we thin back to 3 stems, keep the largest one, and then a couple other neighbors, try to distribute them around the tree a little bit if we can. And then the third one is an untreated control that we want to compare to. So we really want to see what happens when we don't do anything. So those are our 3 treatments, very simple. We replicate that at most sites. It's 5 replicates at each site. In one case, we had some extra time on our hands, so we did 7. And then we have 13 sites around Northern California. Here's a map of our sites. The 2 northernmost are up near the top there, the Butler and Day fires. The southernmost are the King and the Power Fire. And you can see some of those others distributed in between. So, and you'll notice some of those are highlighted in different colors, and I'll explain that in a moment. Okay, so the sprout study timeline. This is how it works. We start, we'll call 0 is when we have a wildfire for our study. And then we wait some number of years, anywhere from 3 to 16 in what we've done so far. And then we come in and we establish these treatments I just described. Then we may take some observations on those oak sprouts. And then we wait 3 years and we come back and we make some more observations again, so we can see what's happened dynamically in that period. Then hopefully what we will do is we'll come out in another 3 years and we'll do it again, and then another 3 years and we'll do it again, and so on. And if you'll notice on the slide there's a place where it says today. So we're in the middle of the second 3-year period right now. But notice in between, so far, we've already lost 3 sites. The pigeon fire we burned up this last summer in 21. And before we even finished the first 3-year measurement, we lost the mill fire to reburn and the king fire to marauding woodcutters. So we're not doing too well in terms of maintaining these sites so far. And so I'm not very sanguine about having these out here for a 9-12-year period. If we keep going at this rate, I'm worried that we're going to lose critical mass on this study. So it's just something to keep in mind. So what I'm going to be able to report on is that little orange bar there in the middle. I'm going to give you results from that here today. So these are early results, but this is what we've got. So the sprout study data, just to give you an idea of, kind of what size things we're working with here. Our snags that we started with, before the fire happened, were ranged anywhere from 2 centimeters up to 71 centimeters, a mean of about 16. So that's the diameter. So there's pretty good range in sizes from a little whippy thing up to a pretty stout looking tree, 71 centimeters in diameter. Our sprouting stuff that comes up after the fire, anywhere from 4 to 31 sprouts, and those vary somewhat with the size of the snag. The bigger the snag tends to have bigger number of sprouts. It's a loose relationship, but it is there. And then heights of our sprouts. This is the height of the tallest stem at the beginning of our study. It was anywhere from about 1.7 up to about 8.5. So obviously the 1.7 would be the younger sites that we have, and the 8.5 is probably one of the older ones. Okay. So what the analytic approach I took on this is to take a mixed effects model and taking advantage of a fairly well-known growth size relationship that most trees have. So you take a tree stem, usually there's a good relationship between basal area increment and the basal area of the stem at a given point in time. And so this is one of our sites. This is the Chips Fire. So you'll see 15 dots there. Those represent 15 different sprouts. The green ones are controls. The yellows are thinned to 3 stems, and the orange are thinned to 1 stem. And you can see that in general, it's sloppy, but the yellow and orange, the thin ones, tend to be above the green ones. So we're going to take that relationship there, that approximate linear relationship, we're going to set that aside as a random effect in our model. And so we can focus on our treatment effects. See, did our treatments stand out? Okay, so we shove all that into a mixed effects analysis. We get a ANOVA table, and call your attention to the 2 red numbers there. Those are our estimates from the ANOVA for 1 stem and 3 stems. Okay, and these were reparameterized when I did this so that those mean a comparison with the control. So that's what falls out of it. So a number greater than 0 means you got a boost in increment of the largest stem of the clump above what would have been with a control. If it was negative, then it would mean we lost growth. So what we see is we got a positive growth response for both 1 stem and for the 3 stem treatment. And as we might expect, the 3 stem treatment's considerably less than the 1 stem treatment. And statistically, we're not allowed to say statistically significant anymore, but the p-values are very small. So what that suggests is we have a signal here. It's not all noise. So we have a distinct signal of a treatment effect. And just so you see what that means, and this is going to vary by tree size now, right? So you have to think about what size tree are we looking at. Well, if we start with a 5 centimeter stem diameter and we thin to 1 stem, that translates to a mean increase of about 70% in basal area increment. And if we treat to 3 stems, about a 25% mean increase in basal area. Okay, so just to show what that looks like, this is just a visual aid what it looks like after 3 years. If I just for a little better look at it, let's extrapolate for 6 years and say, what do we got after 6 years? If we start with a 4 centimeter stem, we've got 6 centimeters after 6 years. We've got 6.6 centimeters after 3 and 7.3, or if we thin to 3, and 7.3 if we thin to 1. So yeah, we get a little more basal area. And of course, it'll be more pronounced over time if that trend holds. So we can only say for 3 years and then extrapolate now. We really need to come back and remeasure these to see if that really holds. Okay, so it appears that we accelerate growth on stems, and especially if we thin to 1 stem. So that might suggest maybe we should just thin to 1 stem if you're going to do this, but maybe not. We might have a problem with resprouting. So let's look at the resprouting, the second half of this thing. Do we resprout? So we'll start off by looking at what happens if we thin to 3 stems. So you go in, you thin to 3 stems, ask the question, do we get any resprouting? And the answer is, well, not very much. Okay, so we're getting a mean resprout here of 0.22. So that's, if you thin to 3, that means on average, if you come back after another 3 years, you've got an extra 0.2 sprouts. And oops, dang it. And about 87% of those had no resprouting at all. So we did effectively suppress resprouting by thinning to 3. We get less growth, but we get hardly any resprouting. And when we do, notice it's very few. It's 1 or 2. Okay, so thinning to 3 stems pretty much suppresses that, and it looks sort of like a nice, well-behaved Poisson distribution. What happens if we thin to 1? Well, something very different happens. If we thin to 1, we get a whole bunch of resprouting on average. We get 4.3 resprouts in that 3-year period. and it's a very ragged distribution. It's actually it's a negative binomial, so it's got a long tail on it. Some of them are up around 20, over 20 stems sprouting back, just by taking out those extra 2 stems. So what this suggests is if you're concerned about resprouting, you might want to hesitate on thinning down to 1 stem. I will say their little caveat on that is that about 1/3 of the ones that we thinned to 1 stem did stay there, but the other 2/3 we could sometimes get quite a bit of sprouts coming back. So this just show you what it looks like. This is a little oak thinned to 1 stem there on the left, and then 3 years later you can see it's all these little whips coming up. And so that's what we think you probably would want to avoid if you were actually going to do something like this. Okay, so a little bonus here, and just we wanted to see if we could learn anything about acorns, mass production in these things. Specifically, we'd like to know, do our treatments affect that? And the quick answer to that is I have no idea. And unfortunately, and the reason is because it turns out there's a lot of variability happening with acorn production. So just to show you at the start, and this is very simple, just look what percentage of our sprouts had acorns by age. So, and what you see when we started this study, the younger ones didn't have any, but the older ones, we had some. The one that says 14, those are the 3 sites we have in the Power Fire where you're going to be going tomorrow. And you'll notice that one, we weren't getting much acorn production there. But on the 11-year-old site and the 16-year-old site, by that time, we were getting pretty good production. McDonald also says that acorn production takes 30 years, but that's from seed. So what this suggests is, yeah, after sprouts, they bounce back quite a bit quicker. When we remeasured 3 years later, we had acorns on most of our sites, even the youngest one at 6 years. But the Power Fire still, interestingly, not producing very many acorns. And the number of acorns did increase over time. So mass production is ramping up in all of these places. But that's about all we can say, is that the mass production does bounce back quickly, certainly a lot less than 30 years, but it also appears to be highly variable. And so you got things going on like edaphic variation and slope and aspect and elevation. And so our study just isn't big enough. There's not enough power here to detect what's going on with respect to our treatments and acorn production. We can't really say anything about that. So what? This is the wrap it up here. Thinning sprouts tends to produce accelerated growth on the largest stem. So it'll vary across sites, and it'll vary by size of the stem. But on average, you're going to increase growth of that thing. You're going to get we would expect to get a bigger tree faster out of this. You might be better off in the long run by saving 2 or 3 stems if you're going to thin oaks in order to suppress resprouting. Coming back to that first point I made about the economic valuation, this thinning's expensive. And because there's no market for oak right now, there's no way to justify it economically at scale. I mean, you're not going to be able to make any boards or anything out of this stuff. However, there could be uses for this, maybe at a smaller scale. I think of a friend of mine who has 20 acres, non-industrial private ownership with a house that burned up, some years ago, and he's managing his oaks because they bounce back really quickly, and they're much bigger than the pine trees he's got. And he likes having those there. And so he can go out now on the weekend and he thins these things back doing this kind of treatment, and he's very happy with it. You could use it on a small scale, places like campgrounds or viewpoints, things like that. But trying to do this over 1,000 acres would be tough, and it would be really expensive. And then acorn production, yeah, we really can't say if we're having any effect on acorns or not. What would be next? The longer term results, we'd like to know, do these hold over time? And we just have to wait to remeasure these things and see how it pans out over time. And the other one would be other species. Does this, whatever this happens to be the results, the long-term results, they hold the same for, say, Oregon white oak or tan oak. I know, for example, that talking to Lynn Webb at Jackson State Forest, they're already doing some thinning of tan oak sprouts this way to see how they respond. So it's not a study per se, it's just a demonstration. But so there is some interest in this. So that's it. I don't know, maybe there's a time for a question, maybe one, but that's what I've got.
Excellent. I think, Stacy, we might have time for one question if you want to read one off the Q&A.
Sure thing. So, can accelerated growth create a weaker trunk, resulting in future increased breakage?
Well, I suppose that's a theory. I guess maybe we'll find out if we see that thing happening over time as we watch these things. Yeah, that'd be speculation on my part. I don't know.
I think we still have time for one more, which is, would single stem oaks serve a different ecological benefit?
You know, that's an interesting question. And, you know, I think, so what are the value of these oaks other than they look nice when they're a tree? You know, there's a lot of wildlife usage of oaks. I know that oaks are preferred nesting substrate for a lot of species of birds. So a question would be, do these tree-like oaks, do birds favor those over nesting in little shrubby things, and, you know, they look closer to the ground? I don't know. So there could possibly be an impact on nesting habitat, something like that. And then certainly if you can get to a big guy, you know, for denning, for mammals and things like that, you know, you need the big ones for that. So that might suggest that there would be some wildlife advantages there. But I think that's a good question. It's a good question.
Okay, well, great. It sounded like we were able to answer a few questions in the Q&A. Those that didn't get answered, let's bring those back up in the panel discussion. So now we're going to move on to our next presenter, who is Dana Walsh. And she's going to be talking about lessons learned in regenerating post-fire landscapes. And this is particularly of interest, I think, to all of us. And hopefully she can share some really great insights on the King Fire and some of the work that she did there that will help us plan post-fire restoration in other landscapes. So Dana, I'll let you take it away.
Thank you, Becky, and hello, everyone. So let me quickly share my screen, and I will make sure that this works out. Okay. Everyone should hopefully see this, and I'm going to go ahead and start the PowerPoint. So my name is Dana Walsh, and I am with Pacific Southwest Research Station, state and private. Let's see, this screen sharing thing is blocking my ability to get to my menu, which is kind of annoying. Let me pause real quick.
If you have a PC, you can also hit F5 to start a
It
presentation.
should be good, and I should be resuming sharing. So there we are, should be good to go. Okay, so in recent history, I was a implementation silviculturist on the El Dorado National Forest, also planning. So a lot of this is based on my recent experiences on King Fire, and then some other additional fires that we've continued to have that I continue to provide input on.
Sorry to interrupt. We're still seeing just the PowerPoint.
You should just be seeing the PowerPoint.
Do you want to make it presenter view or?
Oh, is it not presenter view?
Right. Or it's not presentation mode.
Oh, shoot, it is on my screen. Interesting. Okay, let me, oh, I know what's going on. Okay. Okay, let me do this real quick. Sorry about that. Okay, I'm running 2 screens and Zoom does not like it being on a different screen. So
I thought, yeah,
sorry about that.
no worries. There we go. That looks great. Okay, keep going. Thank you.
Okay, so that's working. Yeah, let me see. Ah. Okay, starting from here, I guess. Okay, so the first and biggest lesson that I learned during my experiences that I really like to showcase, you know, all of these things that are really obvious that I had to learn the hard way. So there is a lot of information out there about how to successfully plant and reforest. Most of it, as we all know, is from experiments with smaller areas than we're currently facing reforestation on. So it's a lot dealing with clear cuts, some smaller fires, which definitely do not meet the characterization of our current landscape level, very large patches. But most of that information is still very critical, very applicable. And really, as we are facing more severe droughts, more climatic pressure from climate change, those truths are becoming evidently even more critical. It's still super critical to control early competing vegetation if you want your seedlings to grow fast. You still need to plan for low fuels. And so for successful regeneration, you need to get trees to a fire-safe condition to introduce fire early and often in these areas and keep competing vegetation and surface fuels low. This is critical for having them develop into future forest cover. Additionally, there's been a lot of information developed over the past on nursery practices and seed handling. Those are still critically important and still undervalued in my experience with the impacts that those have on reforestation success. There's lots of questions remaining about other aspects like fungal associations and organic matter, along with other aspects in these novel conditions that we're facing post-fire. However, you know, most of the fundamental practices are still critical. So lesson 1, we all know that it's super critical to prioritize, or at least most people facing post-fire reforestation, post-fire restoration recognize how important it is to prioritize. We've got limited resources, limited seeds, limited capacity, and limited time. So there's tools that have been developed. Most of you are familiar with GTR 270. There's other tools out there and coming out to help prioritization, but just underscoring that, you know, there's areas that fire does benefits and there's areas that need to be prioritized for reforestation. And while you're doing that, you know, the question should be, where can you be most successful given those limited resources? There's all sorts of assessments on post-fire condition. There's assessments on future climate vulnerability. There's historic data, site productivity, likelihood of natural regeneration. So all of these are important to consider. You need to know if you are looking at future fire management, wildlife habitat expansion, or reestablishment, carbon, and think about long and short-term timing and methods to get to where you want to be, to plan a reasonable series of treatments to get there. You won't likely be successful getting where you're going by shortcutting any of the steps that are critical based on those site factors. It's not a one-size-fits-all, no matter where you're putting your treatments. Lesson 2, it will burn again. I should have added several exclamation points at the end of that, but that has been a repeated experience. The 2 photos on the left are from the Caldor Fire. The one in the middle is the Middle Creek plantations that were established after a fire in the 1930s/50s. That area burnt a couple times. And you know, those trees were reestablished. And then the photo on the left is the SPI, Sierra Pacific Industry plantations along Mormon Immigrant Trail. Now, this is not saying that this is the configuration of trees that you have to have for them to be able to sustain a future fire, but the low surface fuel loading, low ladder fuels are critical for survival. There's some mortality here, but it's not having to restart from ground zero. And I think that's where we need to be planning this post-fire restoration is, what can we do to keep from having to repeat the same steps over and over? The photo on the right is the Point Fire, which burnt on Nevada Point Ridge in the King Fire area in 2020. And here we're still looking at, how does 6 years of brush regrowth and of resprouting brush, how does a repeat fire affect its ability to resprout again and the needed retreatment there. 6 years is a pretty good time for a resprouting shrub to get its foot back in the door. Planning for the next fire is part of that. So again, low surface fuels makes a big difference for firefighter safety and effectiveness and ability to use and manage fire in the future to be resilient. So on the left side of your screen, it's much easier to put in crews and equipment. The right side is a safety hazard regardless of whether it's on fire or not. You're not putting crews into that situation in most conditions. Not that you can't have or don't want any of the condition on the right, but back to prioritizing, you need to plan for where it is in the landscape to be maintained and be able to meet your future needs. In the left photo, the trees will be able to survive a future fire under a broader range of conditions and have fire be able to introduced as a management tool and be able to have a lot of those survive. There's little opportunity for managing a future fire in the photo on the right. This ties in critically to lesson 1 on prioritizing the landscape. You need to have a strategy that's both achievable, but also on a time scale that's relevant. And so if you want to get to the conditions of having a future forest, leaving it in those conditions on the right for an extended period of time will also jeopardize your achieving success over the landscape. Okay, lesson 3, controlling competing vegetation early is critical. Not only for survival of the seedlings, but seedlings that fall behind at the beginning never recover the lost early growth. This restricts your options and leaves the forest vulnerable to the next fire, weaker for insects and disease, and makes it tougher to achieve your condition. The photo on the left is a 3rd-year growing ponderosa pine seedling on Nevada Point Ridge. It was established following the King Fire. It's about 3 feet tall, and you've got options here for introducing fire fairly early. I've got a higher tolerance of putting fire in plantations, but I personally would be comfortable putting fire into some of these stands, at this stage under definitely more conditions than the photo on the right. The photo on the right is planted that same exact time. It's that same unit. It's a different part of the unit. Here, shrub control was not as effective, or they missed the spot, something happened, but less than 9-inch tall. The seedling is next to the flag there. I'm pretty sure you really have to struggle and look in there to see it, but there is a seedling. It's next to my foot. And you just see the difference in growth. You see the difference in ability to survive fire. The other piece to that is waiting to control shrubs is not as good as controlling them early for multiple reasons. So this is not saying that you need to spray everywhere, but recognize that if you are controlling shrubs, getting in when they're small, you're going to be more effective. You're going to use less herbicide, and you're going to have less of a need for retreatment. If you're restricted to hand treatment, you're going back there every year for multiple years, and the condition on the right is still better to start with than the condition on the left. So this early control of shrubs is critical no matter what type of treatment you're doing. The area on the right again, though, would also have a much wider and easier ability to put fire into to help with managing. So this again is King Fire up on Nevada Point Ridge. The photo on the left is 5-year shrub development, where the photo on the right was 1-year shrub development post-fire. Lesson 5, soil is important. So as I was mentioning before, we're looking at much larger high severity patches than we did historically. Historically, these stands, as we all know, were subjected to fairly small openings. And so adjusting to 10 to 30 to 50,000 acre openings that we're putting seedlings into is a brand new concept. we know that the relationship between seedlings and shrubs is complex. And so when we were looking at some survival issues on specific units on Nevada Point Ridge, we found that too much shrub control can also potentially lead to poor survival. And so there's information out there. Fertel et al. 2022 just came out talking about the interactions of shrubs and seedlings in fire frequent stands where you do not have these large openings. So there is, a little bit of a difference there, but there is a complex shrub dynamic with seedlings. And so too good of shrub control can also lead to early seedling drying and other issues. So just important to keep in context. Lesson 6. Seeds are a limited resource that need to be planned for ahead of time. And so most people do not recognize the need for cone collection ahead of seedling order. You've got to order at least a year and a half before you're planting. Your cones need to be collected at least a year before that. Most of our conifer species produce cones every other year at best, and a lot of them do not have a seed crop within decades that are worth going and collecting. There's elevation band considerations. So this is a seeds need assessment where you've got those blocks with the larger numbers. That's where we have some orchard seed that can cover some of that. All of those red values are where there is giant needs in seeds to be able to meet expected reforestation obligations. So anytime you have a wildfire, you're trying to match what seeds you have available with where you need to plant. Likely, you probably do not have exactly what you want or you need. You should have some idea about where you're planting each year based on a project site map. And it may end up being more or less a different area that you end up planting based on how the seeds and seedlings come through. For first year seedlings, you're ordering, like I said, at least a year and a half beforehand. So for planting in spring 2023, you needed to be ordering in fall of 21. You also may not actually get what you order out of the planting. So we spend a lot of time talking about where to plant and how many seedlings and what to plant. But then when it comes down to it, what grew could be vastly different. So this is, one of my multiple years of experience in ordering seedlings and having proportions that I wanted to put on the landscape. And then what grew comes in as a very drastically different number. And what meets, again, recognizing that nursery practices and seedling quality of what goes out into the forest is critical for seedling survival. What actually meets standards for being able to successfully be planted is even smaller. And that can really affect how your future stands are composed and able to develop. Additionally, you're matching seedlings with planting areas. So you don't want to be too far ahead of the game and doing your site preparation that allows competing vegetation to come in. So you really want to be site prepping about the summer before you're planting in the fall or spring. If you're much before that, it leaves a lot up to chance. However, contracts have to get awarded and implemented, piles have to get burnt, and some areas may end up having good natural regen where you expect it, and other areas may not have any. Roads may not be available when you need them. Contracts may not get let in time, especially planting contracts, which have to happen early in the year during specific soil conditions. And so there's these things that come up each year where you're planning on what happens and you have to be flexible on how you actually get those seedlings out and where they actually end up. I'm glad Jessica's going next because she can talk a lot better about the seed sourcing and the needs for making sure that it goes where it should go. Additionally, we talk about survival. And so there's a lot of talk about how many seedlings to plant in areas. And not a lot of talk about what's actually surviving and why planting numbers do not necessarily match numbers of what is established and growing there. And so you may need to plant at higher proportions and higher numbers to be able to get a species survival composition that you're looking for. The graph on the left of your screen is about 70 to 120 trees per acre survival. The large blue block is ponderosa pine, and then you can see smaller proportions of other species. The block on the right is the standard ordering that I was doing for the King Fire, really trying to have, a lot of what we had prioritized when we're planting was ridge tops. So a proportion of ponderosa pine is super important, but also trying to get a good component of sugar pine and other species into those mix. And in addition to the issues of getting the stocking from the nursery, you can see that survival of species other than ponderosa pine is just really impacted in these sites. It's not a condition that they are happy establishing and growing in. So big consideration to keep in mind. And then of course, lesson 8 is things will continue to change. Roads will wash out, snow will fall, and you've got to plan for flexibility. It is a multi-year effort doing a restoration project with multiple entries, and it is a long haul. So good luck. And with that, that is the end of my presentation.
All right, thank you so much, Dana. That was wonderful. I think there was a lot of great take-home messages that I think we can start to think about when we plan in the Caldor Fire. And just speaking in the thread of flexibility, I think Stacy and I noticed that there was a slight timing glitch in the agenda. So I just want to give everybody an update on what the timing looks like for the rest of this morning. We'll have Jessica next at 9:50 to 10:10. Then we'll take our break from 10:10 to 10:30. Oh, great. Thank you so much for putting up the agenda. So you get a slightly longer break, but that depends on our transitions between speakers, whether or not you retain those 20 minutes, we shall see. Then after the break, we'll have Malcolm at 10:30 and then Rob at 10:50. And we'll have a slightly longer panel discussion, just a few more minutes before we break for lunch at noon. So I apologize for that. I think we had a speaker drop off from the morning session and the times didn't get adjusted. Okay, so with that, we're going to move on to Jessica Wright, who's from the Pacific Southwest Research Station with the Forest Service. And she's going to talk about the California seed zone map and post-fire restoration in a warmer future. So Jessica, I'm going to pass it over to you to share your presentation.
Thank you. Let's see. Oh, I see the problem that Dana had. The little Zoom menu covers up your PowerPoint menu. Thanks for the invitation to speak today. I'm really glad I get an opportunity to share the work I've been doing. I am a research geneticist with the Pacific Southwest Research Station, and I'm going to be talking about work I've been doing with regards to choice of seed source in post-fire reforestation projects. My email address is on this slide. If there are any questions, please reach out to me. I'd be happy to send any information I can. So as Dana gave a great introduction there, I am focused on that question after a decision has been made to plant trees. The silviculturalist has to send email over to the nursery and order the seeds to be planted. And my work is focused on how information about climate and adaptation can help influence the success of plantings in that decision of what seed sources to order. And so in California, we have a seed zone map. This is the seed zone map. I like to use this picture because it makes it look really old. Because it is really old. It was developed in 1970. There's one map for all tree species, and trees are considered to be safely moved within a 500-foot elevation band within each seed zone. And as Dana pointed out, cone collecting is really critical. And one of the things I've actually really come to respect this map for is it really does help determine the cone collecting needs for the region. That is, it's easy to look to see how many cones you have in each seed zone, or how many seeds you have in each seed zone and seed zone elevation band, and determine where things are lacking and where additional collections would be useful. But there's only one seed zone map for all tree species, hardwoods, oaks, pines. Really, when it was designed, it was really thought about those critical timber pine species. And so how it applies to other species is less clear. So the goal of our research has been to develop a more informed use of this map, especially in a changing climate, to maximize the success of reforestation projects. So our approach has been to use provenance test data, both old tests and new ones, and I'll talk about that in a second, and then apply these results to climate data and the California seed zone map. So provenance tests, to me, are the gold standard for testing how trees grow in a novel climate. We've been planting them for almost over a century now. So there is historical data available, but there are also new tests that are being planted and evaluated. And I'll talk a little bit about ones we're working on here at PSW. So this is an example. This is a white fir test that was planted by PSW in the 70s. The blue dots show the planting locations, and the orange dots show where the trees came from. And so you see trees are being moved from very different locations to new places. They're coming from, they've come from an environment with a different climate than where they're getting planted. And then they're being followed for growth and performance, which is going to tell us, which is pretty much exactly what's happening, in a reforestation project. You're taking seeds and you're putting them to the ground, and you want them to grow and perform well. And here we're getting data on how that's happening in an experimental setting where things are getting moved farther distances than say a seed zone elevation band. So I've been working with funding from CAL FIRE with a postdoc, Joe Stewart, who's been gathering up provenance test data from a bunch of different species. Today I'm going to talk about 5 of them. And some of these tests, the lodgepole pine test, for example, was established by the British Canadian Forest Service in the 1967. And there's a gazillion planting sites and a gazillion plus trees. It's a huge, huge test. But you'll see all of them are up in British Columbia. The idea was to look at seed transfer in that area. So while there are a lot of dots on this map and a lot of different provenances getting tested, you'll see that there are not a lot of planting sites in California, and that while this data is really great and really informative, I would argue that more data is always a good idea. And so I'll talk about some new tests we're establishing also in a second. So this is the basic sort of cartoon illustrating the hypotheses here. So if a tree is locally adapted, that is, it grows best in the climate where it comes from, then the blue curve is going to show you, it's going to follow the blue curve with the highest performance, highest growth rate, or whatever your measure of performance is at a change in temperature that is essentially 0. So that tree is planted into a place that has the same temperature as where it came from. However, if we see something we call an adaptational lag, where the tree is adapted to a different climate, say a climate that existed before climate change, then we might see better performance when a tree is planted into a place that is colder than where it came from. Just to kind of show off how much data Joe analyzed, here's all the data points in a giant cloud that's undistinguishable or uninterpretable. And these are the results he found. So you see there's that dotted line at 0, and you'll see that all of these curves peak to the left of 0. That is to say, we see evidence for adaptational lag in these 5 conifer species. And that's important to say that trees, so we collect from a seed zone and elevation band, but already they may not be adapted to that seed zone or elevational band, but in fact adapted to a colder location. And thinking about how a planting site is going to become warmer in the future under climate change or under our climate change models right now, that's an important thing to think about if you're thinking about how a tree is adapted to the climate where it came from and the climate where it's going to be planted. And what does this change in productivity look like? This is just actually on a university campus in British Columbia. This is lodgepole pine. These guys were all planted at the same time, and you'll see that the curve here on the graph and the curve in how the trees are changing over time here. You'll see that this is what this curve means. This is the reduction in productivity for transfer. So these trees came from a much colder climate, And these trees came from a warmer climate. So here are the more productive trees and here are the less productive ones. What does that mean in terms of changes loss in tree volumes if we don't select seeds that are adapted to their climate? The size of these error bars are the result of, so that the shadow here is the error bars around this estimate, and really is a result of how many trees were planted. Remember, the lodgepole pine had the really large planting with a lot of trees, and ponderosa pine had a lot less. But overall, the conclusions we make from this data are the same, that if we, so that 0 here is the ideal climate for this particular seed source. And if we miss that by 2 degrees Celsius, we see something like a 12% decline in productivity. If we miss it by 3 degrees Celsius, we see an over 25% decline in productivity. And so that means that the trees that you're planting, if they're missing their ideal climate by 3 degrees, are going to be a lot less productive, less smaller than, and they're going to grow slower, and they're not going to get to that place that Dana was talking about of being able to introduce fire faster for a much longer time. So we have all these tests, and as I mentioned, it's great data to work with, but I would argue we still need more. And so we've been working to establish new tests here in California. I also think, as Dana really pointed out nicely, that the post-fire landscape is rather different than sort of the landscapes that these earlier tests were put into. These were kind of more clear cuts and smaller planting sites, whereas these post-fire landscapes are much larger and I think have unique properties. So working with Dana, we established 3 planting sites on the King Fire, planting ponderosa pine and sugar pine, and then collaborating with Emily Moran at UC Merced, where we have been actually incorporating genomic data and looking at how the genotype, the molecular genotype of the trees relates to their performance. And this was kind of cool because Emily was doing work at the Chico Seed Orchard, looking at climate of origin of the trees growing in the Chico Seed Orchard. And then I was planting trees from the Chico Seed Orchard into the King Fire. And so being able to relate those to that data set and collect data from the surviving trees on the King Fire is going to be super informative in terms of understanding how that genomic variation associates with performance. And I have a meeting with Emily tomorrow to hear about the latest results that are coming in. I'm pretty excited. We are seeing differences in growth of those trees by elevation. So this is height in ponderosa and sugar pine. You'll see the ponderosa, as you'd expect, are taller, but there's definitely variation across the different sources. Another study we just put in this spring was in the Concow Basin, on the Campfire burn scar, and we planted 12 sources of ponderosa pine and 12 sources of incense cedar. Incense cedar is a species that's getting used increasingly more, but there's actually very little genetic data about it and how adapted it is to its home locations or how it sort of interacts with the seed zone map. So we've been looking at ponderosa pine and incense cedar in the Concow Basin. I'm a big fan of zip ties, so we have a little pink zip tie here to indicate which source the cedar tree came from. So we'll be able to go back and monument it properly after it's been established, but we use those zip ties to identify species when you have a gazillion trees in a planting bag. This way you can keep track of which trees came from where. And the basic layout, it is in a grid. There are 4 planting areas, and this is most of one of the planting areas. So it's a fairly large experiment. It also includes a silvicultural component that Chris is doing, looking at how species mixes impact productivity, and having different combinations of 1, 2, or 3 species together influences how productive a planting area is. But what I really want to talk about today is our experimental network, and we're looking at assisted migration and silviculture. And this is with scientists from both PNW and PSW, geneticists and silviculturalists, looking at essentially testing assisted migration across Washington, Oregon, and California. And we're looking to establish about 20 to 30 planting sites. And as Dana said, it takes about 1.5 years to order seeds. So we're currently trying to develop our network of sites. So if anyone is, say, planning a reforestation project on a fire, I would love to and be interested in putting in one of these sites. I would love to chat with you about it. We've got a number of sites developed here in California and a lot up in Washington and Oregon also. The basic design is to compare the success of 4 different seed sources. So taking a local seed source, an early century, a mid-century, or a late century seed source. You could think of this as like the current temperature, 1 degree warmer, 2 degrees warmer, 4 degrees warmer. And again, they get planted out into single source blocks. These are each half an acre. So the total acreage here is an 8-acre square. So we have 4 replicates of each of the sources. And then the little circles indicate the sort of measurement plot areas inside each of the single source half-acre plots. And we might expect this little cartoon of what we think might happen. So the local trees do okay, but really it would be the early and mid-century trees that had the best performance. But the late century trees maybe couldn't manage the colder temperatures that were happening at the current times, and so might be smaller overall going forward. One of the super cool aspects of this experiment is that it is going to be the assisted migration piece is going to be replicated against a set of silvicultural treatments. And the idea with these treatments is to really work with land managers and determine what information would be most useful for them in terms of their reforestation projects, and work that into our design so that we're doing a large network of plots across 3 states, but at the same time developing actionable information and data for land managers at their local forests. So it could be seed sources like bare root versus container stock. It might be using shade cards. It might be herbicides versus grubbing versus mulching treatments, or mulch mats, or whatever treatments that the local managers are interested in testing is what's going to go into this. And sort of the control from an experimental point of view is whatever the land manager was going to do anyway, if we hadn't talked to them, that's the control. And then sort of what we change will then be the test things that we're testing. So again, we're looking to establish a large number of these plots across 3 states, and are definitely looking for more sites. And so again, if you would be interested in learning more about it, I have study plans and briefing papers and all that kind of stuff I can send, and I'd be happy to set up a call to talk more about it. So how do we use these results? So the idea is to take these expected reductions in productivities, remember the curves and the smaller trees at the ends of the curves, and apply that to the California seed zone map. And while doing that, looking at modeling current and future climates in each seed zone and elevation band. And Joe's put together, the postdoc working on this, again funded by CAL FIRE, is put this together into what we call the Climate Adapted Seed Tool, CAST. And CAST now lives at our website, reforestationtools.org. And I'll try and put that into the chat in a little bit. I can't put things in the chat and talk at the same time, but later on I will put it into the chat. So here's just a screenshot off of the CAST tool. So I chose a planting site in the Creek Fire, kind of near Shaver Lake. And so that's the blue pin there is the planting site. And then using the provenance test data for the lodgepole pine test that I showed you, those curves I was showing you, estimating the decline in productivity for the different available seed sources. So the first one listed there is the local seed source. So this planting site is in seed zone 533 at a 5,000 foot elevation band. And if you use that local seed, then the data from these real life provenance test trees suggests that you would see a 20% decline in productivity. But that if you selected the next best seed zone, the best seed zone, which would be 532 from 3,000 feet, and that's highlighted in blue here now, that you might only see a 1% decline in productivity. And then Joe also went ahead using FIA data to calculate expected changes in carbon sequestration if a different metric besides productivity is useful for making a decision in terms of how much carbon might be sequestered after 80 years of growth in this planting spot using these different seed sources and different declines in productivity. So again, this website is available to help provide information about how growth in provenance tests relates to seed sourcing and modeled future climates in a planting site, and how choice of seed source could influence the success or the productivity of the seedlings that get planted. So my take-home message, the California Seed Zone Map, it's been around since the 1970s, and it guides us for seed transfer and for cone collecting. There's only one map for all species, and given it's a static geographic map, there's really no way to account for a changing climate using the map. So we're trying to explore how we can use a map in a changing climate, expanding what data is available to make these decisions, and trying to help inform seed transfer for both reforestation projects and effective use of the Cal Fire and the Forest Service seed banks. And there are way too many people to thank everyone for all of their help. So I'm just going to focus on my funding sources. And we've been continuing to work on this, and we'll be planting more trees soon. So thank you very much.
Excellent. Thank you so much, Jessica. Stacy, I don't know if we have like a minute for questions. Are there any questions that popped up in the Q&A or the chat? If you're speaking, Stacy, we're not hearing you.
There we go. Microphone down helps. So let's do this quick one here. Maybe it's not quick. Quick read. So regarding moving trees, has anyone looked at whether naturally regenerating trees self-selects for genetics that grow better in hotter or drier temperatures?
That's an interesting question. There's definitely, especially when you have areas that have like beetle kill and drought, whether or not the trees that are remaining and still producing cones, if there's, Joe Sherlock, our regional silviculturalist, like to say special magic in those seeds, because they're still alive when there are a lot of other trees that are not. And it has not been directly tested. I would expect naturally regenerating trees, seedlings to have come from local trees. And Joe's results, I think, do show that those are not necessarily even adapted to the current climate. And so I would definitely be nervous about their adaptation to future warmer climates. I'm a big believer, though, in natural selection and adaptation. So I think the seedlings that don't have what it takes to grow well in an environment are not going to grow well in that environment. So I think that I'll say nature will take care of it, but I don't think we necessarily know, are like directly testing those local seedlings for their performance. We have not actually done that, but just given other results, my expectations would be that they may not be adapted to that future climate of that site.
There I go again. Great, thanks. I think we'll save other questions for later and keep on our schedule. Thank you.
Thank you.
Yep, and so now we'll take a break and we'll reconvene at 10:30. So be back at 10:30, everyone, for the next two talks before the panel discussion. All right, hopefully everybody is trickling back from their break, and we'll get started here in a few moments. Malcolm, if you're ready to start screen sharing, that would be great, so we can get your presentation up and running.
Okay, let me see if I can get this going. Is that visible to everyone? Great.
Yep, we can see it. All right, well, we are at 10:30, so hopefully everybody has gotten back and had a chance to stretch, and we're going to get started with our next two talks before the panel discussion. So we'll have Malcolm North speaking first. Malcolm's from the Pacific Southwest Research Station, and he's going to share some information from planning and implementation of prescribed burns in the power fire, and I'm sure some other nuggets of knowledge this morning. So take it away, Malcolm.
All right. Thank you, Becky. Actually, I am entirely to blame for having the wrong title in this talk outline. So I'm going to talk about something else. And it is my fault because I don't think I got an updated title to Becky. But if you're wondering what I know about the planning and implementation of prescribed burns, very little. All that work was done by Jesse Paul and Rick Hobson of the El Dorado National Forest. So my apologies for pulling a bait and switch on you in terms of the content of this talk. But the revised title, or I think a title more consistent with what I'm going to talk about, is at the bottom of the slide of say, do wildfire treatments and prescribed fire help restore resilient forest conditions? And that's going to be more the focus of what I'm talking about today. So a little bit of context as to why this question I think is relevant and interesting, and that the Power Fire provided a really unique opportunity to take a look at it, is a little bit of background from a paper that Rob York and I and a bunch of other people did about a year ago that we titled Pyrosilviculture. And that paper analyzed, or at least looked at, what the current conditions in the Sierras were in terms of rates of treatment and what was impacting much of the landscape. And so I'm just going to present some nuggets from that paper to give you some sense of context as to why I think this study is relevant and what it was kind of going after. So that paper looked at, of the 13 million acres of Forest Service land in the Sierra Nevadas, which is what it focused on, using fire history records and fire scar studies. It made a kind of ballpark estimation that in that 13 million hectares, you probably would have had about 620,000 acres a year of fuels reduction going on from fire in pre-European times. For comparison, the current Forest Service rate of treatment is about 63 to 93,000 acres per year. So you can see almost off by an order of magnitude in terms of treatment rates versus historical rates. But interesting comparison to that is that annual wildfire acreage within this 13 million acre area averages about a little less than 250,000 acres a year. And as you can imagine, that's hugely variable year to year, but that's the 10-year running average over this period of 2011 to 2020. And I think a lot of times when we're looking at the aftermath of a fire, much of the post-fire management is focused on the high severity areas, and particularly where and if salvage logging will occur and whether planting is going to occur in these high severity areas. But I think one thing that sometimes we neglect is that often about half of, if not more than half, the acreage in wildfires has burned at low to moderate severity. And so what this study was motivated by is assessing whether you have kind of a positive treatment effect from this low to moderate severity burn going on within these wildfires, and whether we might be able to leverage that. So in any sense, one of the suggestions from this paper was to look at these low and moderate severity fires areas and look at whether you might be able to restore both the conditions as well as improve their resilience by thinning ladder fuels to maybe harden the site better against crown fires, and also possibly apply prescribed fire to reduce some of the increasing fuel loads that result from the dead trees becoming snags, becoming large surface fuels that often occurs about 7 to 20 years after a burn. And if you were able to leverage all of these low to moderate severity areas, you would increase current treatment rates by 250 to 325%. So you get a fair amount of bang for your buck out of the benefit of wildfire by focusing on these low to moderate severity areas. And the Power Fire really provided a great opportunity to kind of examine this and see what the effects of wildfire were in these areas, and because of the intent to prescribe burn some of these areas afterwards, to also examine that question. So that's in essence what is I'm going to talk about today, is this question we had, the central question that we were asking and with this study was, after the 2004 fire in the low to moderate severity areas, what are the current conditions of 4 main components to forest stand structure and current forest conditions? The overstory trees, the fuels, the tree regeneration, and the understory shrub and herb cover and diversity. How did these conditions change after applying prescribed fire? So first we were assessing what they were like before the prescribed fire was put in, generally sampling those conditions over about a 4-year period from 2015 to 18. And then after fire was put in, looking at how these treatments affected the 4 forest conditions and whether they help to restore resiliency back into the forest stands. And by resiliency, I'm not going to kind of dive into all the problems with that term and what it might mean, but we were basically focused on, did it increase the ability to have a positive fire outcome in the future, i.e. less crown fire and more surface fire? And did it reduce tree density sufficiently to infer that you'd have a better response during a drought? So in particular, we were focused on trying to sample areas that we knew, or at least that the El Dorado had planned to burn in the future. And so on the left-hand side map, you can see that there were 10 different units that were listed, at least initially, as areas that were being considered for prescribed burning. And I think, if I remember right, about 6 of these actually have been implemented. And working with Jesse Plummer in particular, we focused in on which of those 6 to particularly sample, and then established a plot network within those areas. And in the right-hand side, you can see what Unit 4 looked like in terms of the plot network that was put in. And I want to point out that there was plots put in both inside the area that was planned to be burned, as well as outside of it in adjacent areas, to have kind of a comparison of how the trajectory and the response would change between areas that had been burned just by the power fire and areas that were burned by the power fire plus the prescribed burn that was planned in these areas, and in particular in this one in Unit 4. I thought about inundating you with a bunch of statistics, but realized that it kind of gets overwhelming when you're looking at 4 different topic areas. And particularly, I noticed that the organizers of this meeting were really focused on what kind of information could come from these studies that might be useful to dealing with the aftermath of fires such as the Caldor Fire. What lessons were there to be learned? And so I'm going to mostly just focus on summation of what occurred in these 4 different studies, and then try to translate that to how the results from it might be useful in terms of the Caldor Fire restoration and other fires in the future. So the assessment of what conditions were like after the power fire, but before the prescribed burn treatments were put in, I've separated into these 4 general topics. So the overstory trees, there was about in the low and moderate severity areas, they averaged 14 and 32% overstory mortality respectively, pretty consistent with what the ranges of low to moderate severity are defined as in terms of percentage of overstory basal area mortality. The fuels, interestingly enough, because you'd had 12 to 15 years after the power fire, had built back up to a level at which they were probably at sufficient abundance to be able to carry a surface fire. But at least in terms of the smaller fuel classes, what we call the 1 to 100 hour fuels, we're not able to at least generate enough radiant convective heat to support crowning. However, there's a much different story with the 1,000-hour fuels, because if you think about the trees and the branches that are coming down after our trees died from the original power fire, you can end up with pretty high accumulations of larger surface fuels. And that indeed was the case with what we refer to as the 1,000-hour fuels, which I'm used to thinking about this in centimeters, but I believe are larger than 3 to 5 inches in diameter. But the potential loading or the loading from those higher fuel size classes could potentially produce a torching problem for fire, given the 12 to 15 year period of accumulation that had occurred since the 2004 fire. The tree regeneration, as you might suspect, if you kind of clear off and expose a lot of mineral soil, and yet you have quite a bit of live overstory trees to provide seed source, the natural recruitment was actually quite high in these stands, about 200 to over 1,000 seedlings per hectare. So very healthy regeneration. In fact, regeneration kind of bordering on more trees than you want, and I'll talk about that more in a minute. But unfortunately, you do have the pattern that you find often in the Sierras, which is the bulk of the regeneration was in fire-sensitive species, particularly white fir and incense cedar, and that the tree regeneration tends to be very highly clumped. The understory response looked actually to be quite good. You had an increase in both cover and diversity of herbs. The one kind of exception to this is in the moderate severity areas, the fire burned hot enough to actually really start to increase the shrub cover, in which you have shrub cover often dominated by pretty high levels of ceanothus, bear clover, or manzanita after these effects. So this was the kind of summation of these general 4 different characteristics after the initial power fire treatment, 12 to 15 years after the power fire. So what happens 1 to 2 years after the prescribed burns are put in? And again, we had established these plots and monumented them so we could sample the exact same circular plot at each particular monument, both before the prescribed burn and then after the prescribed burn as well. The mortality was really highly variable, but often the mortality that resulted from the prescribed burn was associated with either adjacency of a ladder fuel or logs that had come to rest or been very close to resting against tree boles, as you can see in the upper right photo. Something that tends to create long residency times of burning, sufficient enough to kill trees, particularly overstory trees, because of that long duration of exposure to high heats. The fuels, about 65% of the surface fuels and the 1,000-hour fuels were consumed. So pretty good consumption rates in these prescribed burns, which is really nice to see. A willingness to push the fires to actually achieve some fuels reduction, which sometimes produces a more lively fire than sometimes people are comfortable with. But it was very stochastic as to whether a particular microsite burned or not. We had some plots that were in these fuels, in these prescribed fire treatments, that didn't end up burning. But that's the nature of, I think, the beast when you have a relatively stochastic fire response. The only thing that definitely increased the rate or the chance of consumption was when you were on steeper slopes. And generally, most of the plots on steeper slopes did burn. The tree regeneration, you also had about 60% mortality or consumption. Although interestingly in the clusters, and you can see an example of this in the right-hand photo, the seedlings that are on the outside tended to die from the fire, but the seedlings and saplings in the center of the cluster actually often survived, which is kind of surprising to me, because I thought that once you got going or got the fire going with these, it would basically torch off a whole clump together, but that did not appear to be the pattern, at least that we were seeing. But there appeared to be no particular differences between species, and my guess would be is because the seedlings and saplings we're measuring are so small, the fire resistant characteristics of pine were not particularly any different than they were for other species at this point. And the understory, you had a significant increase in herb diversity and a decrease in cover. The shrub consumption was quite low, actually, often less than 20%. But the areas where you did have burning of the shrubs, there was kind of what I would call some warning signs that you had the potential for significant sprouting and dramatic increases in shrub cover in the future. So in sum, I guess I'd say that the power fire's initial treatments, the low to moderate severity, was highly variable, but generally achieved what you were looking for in terms of objectives, which was to reduce the tree density and the smaller surface fuels, and supported pretty high natural recruitment patterns because you had both exposure of mineral soil as well as a remaining live seed source. And it helped to diversify the understory. The prescribed fire further reduced the tree density, which in most cases was still needed further reduction. And so it was a positive benefit, and particularly tended to do a better job of selecting for the fire sensitive species than the initial burn did. The smaller sizes of fuels were also pretty well reduced, which was a benefit. And you had a pretty heavy reduction in the seedling sapling natural recruitment. And I put in parentheses here, maybe beneficial, and that's because some of the density rates of the natural recruitment were so high that you're actually looking for some level of reduction in that density to be able to get it down to more the historical range of variability of recruitment or regeneration in these stands. But I would suggest that there's the big unknown is that you have a problem of potentially significant increases in the future in shrub cover. The models suggest that the probability of fire torching, i.e. passive crown fire production, were reduced, and that the density reduction probably would also increase the drought resilience as there are less straws in the ground competing for limited amounts of water. More fire entries will clearly be needed, and in this case, there was no mechanical pre-treatment, but it's clear that mechanical treatment would allow you to fine-tune the forest conditions a little bit better to reduce that overstory mortality that we saw that occurred from both adjacent boles against the trees as well as ladder fuels next to live trees. I'm not suggesting that that loss or continued decrease in the overstory mortality was a negative, but simply that you could do probably a job of selecting in particular which trees you wanted to hold on to, and particularly have a better chance of preserving some of the more fire resistant pines. So what would be the management recommendations from this study? I think that it does suggest that there's value in assessing low to moderate burn severity areas within wildfires to see where you could use mechanical and fire treatments to further the restoration and resilience goals that we would have in the future. I mean, frankly, in terms of planned fuels treatments at that 63 to 93,000 acre level that currently is what the Forest Service is doing, compared to wildfire producing about 120,000 acres of low to moderate severity, you could get a lot more bang for your buck actually focusing on some of the low to moderate severity areas within the fire rather than exclusively focusing on questions of salvage and replanting alone in the high severity. I'm not suggesting to ignore the high severity by any means, but I think that there's an opportunity to leverage these treatments. Word of caution though, and you can see an example from this, not from the power fire, but from a area in Northern California where I've got a study going on, the Eiler fire, of what shrub cover can look like after a high severity fire. Interestingly, the shot in this photo has trees planted on a 12 by 12 foot spacing. And as you can imagine, survival's not all that good in some condition like this where you get wall-to-wall shrub response. In fact, we counted about 85% mortality of regularly planted or gridded plantings of trees versus actually clump planting, which we tested in an adjacent area, had about 65 to 70% survival. So there's lessons to at least be considered from that, but vigorous shrub response, as Dana was rightly pointing out, is a real problem that is a particular offshoot of these high severity fires that we're producing in droves these days across much of the Sierras. The tree regeneration actually appears to be pretty vigorous from natural recruitment. It tends to be highly clustered. And frankly, this is a concern of mine in a paper that we just put out recently. I think it's worth our while to research exactly what the dynamics of these clustering patterns are and whether they instill better fire resilience into the regeneration pattern. And finally, I think targeted mechanical thinning probably could achieve better burn outcomes, at least more precisely defined burn outcomes, because of that surgical ability to put paint on particular trees and remove what you want to influence fire behavior. And particularly, you're likely to increase the size of the burn windows for a greater range of fuel moisture and weather conditions. And with that, I'll stop. And I particularly want to acknowledge both the El Dorado National Forests and the grad students and field crews that have worked on this study over the years. And I'd be happy to take any questions at this point.
All right, thank you so much, Malcolm. Very interesting to hear the results from the work that's been done on the Power Fire. I think we don't have time for questions right now, but we're going to move into the panel discussion shortly after Rob's talk. So if people have questions, please put them in the Q&A for Malcolm so that we can address them at that point. And so now we'll move into our last speaker for this session, which is Rob York. So Rob, if you want to get your camera turned on and get your talk queued up.
Okay, I think I am there, at least on my screen.
Excellent. Yeah, we see the PowerPoint presentation. Oh, there we go.
Okay, cool. Thank you. Yeah, hello, everyone. I am a cooperative extension specialist with UC Berkeley. I'm currently up at UC Forestry Camp in Meadow Valley. The internet connection, I hope, will be good enough. It hasn't been great throughout these last couple of weeks, but hopefully it'll be good enough. I'm also trying to keep the students away from the Wi-Fi. So I might have to step out and shoo them away, but hopefully I won't have to do that. So I'm going to talk about prescribed fires in young stands, specifically thinking about post-fire reforestation, specifically post-high severity fire reforestation as a prescribed fire treatment. So as a pre-fire treatment where fire means prescribed fire. Okay, so the outline, I'm going to talk about kind of pyrosilviculture in a slightly different context that Malcolm referred to it. Pyrosilviculture and that kind of as the conceptual framework for this talk. So pyrosilviculture and reforestation and young stand management. And then I'm going to speak from experience to some extent. Experience in burning in young stands, so observations that I've had over the last 13 years of trying to actively burn in young stands to kind of to learn about how we can do prescribed fire in young stands. I'm going to speak from research also, focusing on this study called the Treatment Alternatives for Young Stand Resilience, also known as TASER. And then I'll finish up with those 4 highlights that Becky asked for. Okay, so the target audience that I was thinking of when thinking of this talk is not really for those who are planning on wildfire to be the next treatment. Not that that's not a bad mindset to be in. So I'm thinking of those areas across the landscape that are accessible, that we want to invest in terms of the development of forested structures after wildfires. I'm also not really thinking of those who are planning on only non-fire silvicultural manipulations. So those landowners or areas where prescribed fire is not an option and they're just going to use mechanical treatments. Not that that's, there's certainly a role for that potentially, but I'm really thinking about those who are planning on prescribed fire as a tool to influence stand development. So pyrosilviculture, actually can't see my whole screen here, but pyrosilviculture, so I have a couple, this is a definition from another paper on pyrosilviculture from the Canadian Journal of Forest Research, another paper compared to the one that Malcolm talked about. And this other paper describes pyrosilviculture in the context of it being kind of stand level. And so I have a couple of definitions that I like to apply to define pyrosilviculture. The first is the idea of using fire directly to meet management objectives. And the kind of idea here is that we're claiming prescribed fire as a silvicultural treatment. Like silviculture occurs at the stand level. And if we do prescribe fire to meet certain objectives, it is a silvicultural treatment. So it's just that idea of kind of having an objective-based prescribed fire and doing it at the stand level. The second one is the idea of altering non-fire silvicultural treatments explicitly so that we can optimize the incorporation of prescribed fire in the future, right? So not necessarily using prescribed fire, but always thinking about trying to optimize it in the future. Anytime we do a silvicultural treatment, whether it's thinning or whatever it might be, the idea here is that we're trying to alter that treatment so that we can increase the probability of prescribed fire occurring in the future. And you can imagine that involves like altering the structure or the species composition in certain ways so that we can increase the probability of prescribed fire occurring. So I want to give some updates from the TASER study, treatment alternatives for young stand resilience. I've been doing this at Blodgett Forest Research Station. That's in the mixed conifer forest in the Central Sierras. Started in 2012. The idea here with the TASER study is to experimentally explore just burning in young stands. Part of it's just kind of to do it and to document the effects of burning in young stands. Experimentally, what I'm hoping to do is use prescribed fire, explore it as a specific alternative to other young stand treatments that we tend to do. So pre-commercial thinning or vegetation control, that type of thing, or adding prescribed fire as a kind of paired treatment to go along with these other more traditional treatments. And then eventually what I'm really hoping to do in the long run is observe how frequent fire, so through introducing fire several times during stand development, how that's going to play out in the long term in terms of influencing long-term stand development. Okay. For the TASER study, an important aspect here is that I've been using group selection, so young stands that are even-aged cohorts, but they are kind of small in scale, about an acre, right? So I've started using those as kind of experimental stands because I have a lot of them, right? And so a lot of opportunities to burn through them. It does kind of beg the question, like, well, are they really relevant in terms of, when we try to do prescribed fires across larger reforested areas or larger young stands, is that really relevant? I would argue that they are, just because the work that I've done trying to compare, the stand development in 1 acre patches versus 10 acre patches, it's essentially the same. Like the growing space that I see occurring in a 1 acre patch, 1 acre canopy opening, it is the same as in terms of light availability and water availability. It's the same as 10 acres, same as 100 acres. So for me, that means I can be relevant and also have a lot of experimental power because I have a lot of these 1 acre stands available. And it's so far I've burned about 50 stands with separate ignitions, 50 young stands with separate ignitions. So you kind of see how we have benefited in terms of the experimental power, benefited from using 1 acre size cohorts. All right, so a very common question I get when it comes to burning young stands, as you can imagine, is at what point can I do a prescribed fire and not kill all the trees? And so what I've generally found, as you might expect, is that fire-related mortality from prescribed fire declines with stand age. That's kind of what you would expect. I've just been trying to quantify that relationship. So this graph here shows the post-burn mortality. So prescribed fire burn mortality across different stand ages, where this burn was done on the same day. So it burned across different stand ages on the exact same day, right? So from 12 all the way to 100 years old, given the same conditions. If you're looking at the y-axis here and you're seeing high mortality in the 12-year-old stand, that's true. We did get high mortality. That's because it was done during dry conditions, right? And so what I find is that that this relationship holds constant. This mortality and stand age relationship holds constant. It just moves up and down depending on the weather conditions and the fuel moisture conditions. What I call the Thanos effect, killing half of the trees. Yeah, we got that with under conditions, and this is yeah, so the younger stand there is 12 years old, and I killed half the trees when we burned in 12-year-old stands. That was in the very driest conditions that I've ever burned in. So 5.5% fuel moisture, 20 to 25% relative humidity, and I killed 50% of the trees, as opposed to, so it doesn't have, the young stands obviously don't have that same level of kind of being robust against a wide range of prescription parameters, right? Especially compared to mature stands, where in this case, despite the dry conditions, I did kill overstory trees in 100-year-old stands, but it was like 12%, something like that. Okay, so I've also been looking into season of burn. So burning young stands in the fall versus the spring. This is something that's in revision right now. What I've generally found, well, in this particular study where I had replication and I burned in the fall versus the spring, these were 14-year-old stands that I burned in. That's the data that I'm showing you. So this left, the graph on the left is showing the fuel load and what it was before the prescribed fire and what it was after the prescribed fire. On the left panel is in the fall and the right panel is in the spring. So the fuel load, so that left panel is showing a large reduction of fuel load when doing fall burns, and then not much of a change at all in fuel load when doing spring burns. Now, not to say that this kind of difference in fall versus spring burns happens every time, because I have done some spring burns that are pretty good in terms of fuel consumption, but it's just that there's not that consistency. When I was doing spring burns, I have not found the consistency of always getting good consumption, because sometimes fuel moisture is too high, or the DEF moisture is too high, or something like that, as opposed to that higher level of consistency and consumption that we tend to get with fall burning. The upper right graph there is just showing the difference in fall versus spring burning in terms of crown volume scorch. So damage to canopy trees. These are small trees, but like the trees that generally were in the canopy of these young stands. So what I'm showing here is that spring crown scorch was higher. And this can depend on the exact conditions during the burn, but really what I'm trying to point out here is that we can have this situation in spring burning where we're not getting a whole lot of consumption in the fuels, but at the same time we're getting mortality in the overstory. Now, mortality overstory might be an objective, and that's perfectly fine. But if we're expecting that trade-off to occur, like, if we're okay with some overstory mortality as long as it comes with consumption of surface fuels, we're not necessarily going to get that in the springtime. And then that lower right graph is just showing the importance of crown volume scorch in terms of the likelihood of mortality occurring. Okay, pre-fire pruning. This is something that I've also looked at recently. That's in a paper that's in revision right now. This is what I did here is I pruned incense cedar and sugar pine, and I paired individual trees, either pruned or not pruned, as a pre-fire treatment. This pruning occurred the summer before the prescribed fires, which then occurred in the fall and then in the spring. Again, just on sugar pine and incense cedar. These were on 14-year-old stands where the mean diameter at breast height was about 6 inches. And I've looked at pruning a couple times now experimentally, and I think generally what I'm finding is that pruning as a pre-fire treatment, it doesn't save trees. Not consistently anyway. It doesn't save trees from prescribed fire-related mortality. I think just what it tends to do is it just removes the lower branches that would have been scorched anyway. And that upper right graph is showing that there was less crown volume scorch in unpruned trees compared to pruned trees. So you might think, well, pruned trees does avoid some crown damage. But the thing there is that the pruning itself is crown damage, right? So the net effect of pruning and prescribed fire, adding a little bit of scorch afterwards, is that net effect, that total pruning plus prescribed fire effect on crown scorch or crown damage is much higher than just prescribed fire alone would have been if we had not been pruning. And then that lower left graph is just pointing out to, like, it's really about tree size, right? So like when I prune trees and try to see the effect of pruning, the greater factor when it comes to mortality, the factor that's greater than pruning is just the tree size. So, as we might expect, larger trees tend to be more capable of persisting through prescribed fire. That temperature data is just from some thermocouple data that I collected, showing what I think is a buffering effect. So those are from thermocouples placed up in the crowns of pruned and unpruned trees, where the pruned trees just had higher heat pulses going into them, right? Because there's more fuel, because we just pruned and we put fuel at the base of the crowns. And so therefore there's more heat intensity. And also, I think importantly, less buffering of that lower crown. The lower crown's not there to buffer the heat pulse going into the trees. I don't want to hate too much on pruning. I have seen some really good pruning, and I've done this a little bit myself, where if we prune to facilitate winter burning of below canopy fuels, like I've seen that actually work pretty well. This is Craig Ostergaard has done some of this on Sierra Pacific Industries land, where he prunes and then burns during very low risk conditions, those being the winter time. And that pruning, especially if it's ponderosa pine needles, creating that very receptive or kind of a fuel that can dry out quickly in a winter period, then I've seen that be effective in terms of like a pre-fire treatment. All right, another little topic here. Can we use fire I have like this thing blocking my screen. Can we use fire to thin plantations? I think that's what it says. I think the answer to that is absolutely, it can, as long as we always remember that it's going to be a cleaver and not a scalpel, right? So we just lose that. We don't have the precision of a chainsaw when we're using prescribed fire, and we never will. I think consistently what I found is that we can get fuel reduction, especially with fall burns. We can consistently get shrub cover reduction. And then we can consistently increase our height to crown base. These are all things that I've seen occur fairly consistently when burning in young stands. Those graphs there just show the change in the diameter distribution, pre-fire versus post-fire, in spring versus fall. That blue on the graph is showing where the diameter distribution decreased, right? So this is just saying that when I've killed trees, right, with prescribed fire, it tends to be the smaller trees, right? So we're kind of, and that's what we try to do with pre-commercial thinning, at least typically. And so there is that, to some extent, this kind of, at least that function of pre-commercial thinning can be done with prescribed fire. However, it's a cleaver, right? It's a meat cleaver, and so with sometimes we can get unwanted level of mortality. I've done that sometimes, and sometimes we can get unwanted species selection, right? So we don't have the control like we do with the chainsaw in terms of choosing which species go and which species stay. I think the key role of prescribed fire is keeping fuel load development in check, right? You think of stand development and trees developing over time, and a dense canopy developing over time, and then think of the litter input that occurs with stand development. And this, to me, like the prescribed fire with young stands, is all about keeping that development in check, right? So this is from a study where I burned at age 14. And this is actually kind of similar to those of you who are familiar with the firefighter surrogate study, but it's applying it with young stands. So upper left, we have burn only treatment, upper right, mastication plus burn, lower left, mastication only, lower right, mastication plus herbicide. All I'm trying to show here is that when we used fire in young stands, when it was the burn only treatment, we reduced fuel load, and it persisted 5 years after the prescribed fire. Mastication plus burn, it maintained it, because the mastication did add some surface fuel load to the stand, but prescribed fire helped us avoid like an increase in surface fuels, as opposed to just using mastication or using mastication plus herbicide. When we do those treatments, we're not avoiding that development of surface fuel loads. but using fire does avoid that development. Okay. Those of you concerned about the cost, if you think that I guess if you value tree growth or stand growth, there is a cost here when using prescribed fire. I've found this consistently. Not all studies have actually found this in terms of long term, I should say, but what I've found when using prescribed fire in young stands, I'm talking like 13 to 20-year-old stands, I do see a tendency to slow growth down. For obvious reasons, like trees, fires damage trees, right? That lower left-hand graph is just showing stand level growth. This is relative stand growth. So like this is showing compared to the basal area at the time of treatment, what the growth for 5 years after the treatment was. And the burn-only treatment is on the left. You can just look at that one, showing a certain level of growth, and where the mastication plus herbicide grew more in terms of relative stand growth, grew more. Because it didn't have fire, it didn't have fire, and it removed competing vegetation, so the trees got bigger. Or at the stand level, stand growth was bigger. The individual tree level growth responses up there on the upper right graph, and those are some species differences that I don't really have time to go into, but just to say that like I typically expect a reduction of growth of the individual larger canopy trees and also stand level growth as well. Okay, I want to talk a little bit about site preparation. I think this follows a little bit with what Dana and Malcolm were getting at, I think anyway. Site preparation is huge. When I've tried to burn young stands that were not site prepared, and when I say site preparation, I mean pile burning or removal of woody debris before planting. That's what I mean by site preparation. It's such a huge factor with prescribed fire. Because these jackpots of fuel that come from the previous stand, if those jackpots of fuel are there, like there's logistically, it makes it harder to burn, and it tends to, I think, create an extreme level of clumpiness when it comes to fire effects, prescribed fire effects, where sometimes it's actually hard to get those jackpots going, depending on the conditions, or they get going and they produce a lot of heat. And so we can kind of, to me, it kind of facilitates this kind of tendency to either be in one extreme at the or the other. So this is, I know this is kind of complicated, but like when I think through the different factors that lead to high mortality versus low mortality when burning in young stands, this is kind of how I would profile it. Of course, whether the mortality is significant or not depends on our management objectives and our tolerance for mortality. But generally, I think that, burning in the growing season, like I was mentioning, burning in the springtime tends to push mortality upwards. Tree smallness, for lack of a better term. So if trees are smaller or younger, that's another thing that pushes it upwards. Dry, fresh activity fuel load, anything that increases fire line intensity is likely to push that upwards, or planting of fire sensitive species is another thing. Factors that push this prescribed fire related mortality down closer to zero: site preparation, planting of fire adapted species like ponderosa pine. Don't get me wrong, all mixed conifer species are fire adapted, but those that are, I guess, more resistant to fire, like ponderosa pine or giant sequoias, planting those species should logically reduce prescribed fire related mortality. Burning outside of the growing season in the winter and the fall time is what I'm talking about. And then of course, tree size. Now, if you're a manager who wants some mortality, if you're thinking of this idea of using prescribed fire to thin or to facilitate heterogeneity, then there's this, I think, what I found is that there's these kind of combinations of treatments that you can use to facilitate that. Site preparation, I think, is always a good treatment when it comes to prescribed fire later on. When we add into site preparation, mastication, and winter burning, I found that to be fairly effective. A continuous pine litter is beautiful, right? A continuous ponderosa pine litter layer is just a nice fuel bed to do prescribed fire. And then, I can't read that, high tree density plus normal burning frequency. So that's kind of this idea of, even if we start with a high tree density, like that to me it's okay. Like I really like a high tree density if I'm going to be burning frequently, because even if I have a homogeneous structure, high density stand, I know from experience that if I'm doing prescribed fire frequently, eventually I'll get heterogeneity. Like I can guarantee you I will get heterogeneity just through the use of and variable outcomes that prescribed fire inevitably has. Okay. All right, so what I'm getting at here is, like, what would make us a land manager say I'd burn that? What would make a forester say that's a structure that I can burn? Like to me, that's what pyrosilviculture is all about. A highly burnable structure involves multiple canopy tree species, because that's a hedge against fire-related mortality that's species specific. It's a shrub cover that's less than 30%. Dana talked about this, and Malcolm talked about this as well. This avoids extremes in fire behavior. Now, high shrub cover, my experience, it either goes like hell or it doesn't go at all when it comes to fire. High crown bases, this is kind of more of an ergonomic thing, and I think it can limit torching as well if we're waiting until high crown bases via pruning or via just kind of natural crown lifting is greater than 6 feet. Limited jackpots of heavy fuels to avoid extremes in fire behavior. Low snag density, I think, is a no-brainer with prescribed fire practitioners for safety, right? And you can think how post-fire restoration or how post-fire treatments are going to relate to prescribed fire snag density. Like, it's easy to make that connection in terms of safety. Okay. And I was thinking about, I think about what I'm saying here is, like, some of these traditional reforestation practices are pretty good when it comes to prescribed fire. And I think that that's kind of inconvenient for sometimes, because it makes it sound like we're just managing for timber. But like it's coincidence, right? I think if we just kind of put the focus on the outcome being prescribed fire occurring in the future, and having that be the reason why we're doing these post-wildfire treatments, I think if we frame it with that as the outcome, then it's more acceptable. And again, variability will come with time.
Just give you a quick time check, Rob. You wrap it up if you could. Thank you.
Okay, yeah, this is, I'll go right to the highlights. Pre-planting site preparation of fuels is valuable, I think, as a pyrosilviculture treatment. If prescribed fire is the most probable next ignition, then traditional reforestation prescriptions are a good foundation. I think some of those traditional reforestation practices do lead to good burnable stands. Spring burning, I don't want to say, hey, again, I don't want to tell people avoid spring burning always, but there is that kind of uncertainty that, in my experience, in terms of the outcome. And then pre-fire manipulations, I think they can provide an opportunity to burn in the winter time, during the low risk conditions, or at the cooler, wetter end of the prescription. All right, thanks.
All right, thank you everybody for speaking this morning. Now, I think we're in that discussion period. So if folks that spoke this morning can turn your cameras back on, that would be great. And then I think, Stacy, I'll pass it over to you to ask any lingering questions that were in the Q&A. And then I'll encourage everybody that's on to please put your questions in the Q&A. We haven't seen a bunch pop up lately, and I'm sure there's some good questions out there. I know I have a few, but I'll make sure others have the opportunity to ask their questions first.
Okay, so I realize these are coming in at different times, so I think I know who they're addressed to, but I'll ask the speakers to jump in if I redirect the question differently. So there's a few in the Q&A, and then a few, I'll also mention that during the presentation, you might notice that you can go into Q&A and go to answered, and there's a few things like, that were easier to answer through chat, or some things that were added in. So if you ever wanted to go and look through those, you can kind of see what some of the speakers said directly to those questions. But I think this is the first, I think this is for you, Martin, about oaks, I believe, whether or not roots kind of like interact with each other, and is it better to have kind of clumpy formations of oaks? I think that was an oaks question based on the time. And you are on mute, Martin. There we go. Thanks.
Okay. Yeah, I mean, I haven't looked at that, but you know, and I haven't read anything in the literature that specifically would say something one way or the other, but I would assume the roots do interact with one another. I think that's a pretty safe assumption. And so what was the second part of it about whether they?
I think it's about like planting in clumps or having, or like retaining oaks more in clumps versus solo oaks.
Well, you know, yeah, I don't know what to say about the oaks or where they are. You know, we're not planting them. These are naturally occurring oaks. They're on the landscape the way they were there originally, you know, from natural regeneration. So I really, yeah, I don't have any feel about, you know, I really can't comment on clumpiness or that, anything like that.
This also came in like right between two. So it could also be more of a question for one of our, let's see, it could also be for Dana. Maybe it was about replanting. So Dana, do you have anything to add about how roots interacting with each other or replanting in clumps might be beneficial?
So I'm guessing that one was for Martin based on when it came in. When we're planting, the trees are much too small for the roots to have grown into each other. They're definitely, you know, interacting with shrub roots and grass roots that are competing for water. But I think actually, you know, Malcolm and Rob may have more input on, you know, how that develops later and, you know, how those factors influence each other. We do know that, you know, as trees develop, tree roots do engage with each other and that there is effects from clumping.
Rob, Malcolm, anything to add?
I guess I would second that, Dana. I mean, I see clumps out there of seedlings, and I expect it's quite a while before they're actually competing with each other for water and nutrients, just because, I mean, even though they're close to each other, like, you know, there's still a lot of resources generally because of the open stand condition and the lack of, assuming there's not large trees nearby. And so I typically, it looks like they're competing, you know, sometimes because they're so close, but I actually think the water availability that they have is not really related to their neighbor trees, is more related to kind of shrubs, like what Dana was saying.
And we, Hannah Fertel was a student of mine, just came out with a paper looking at tree growth rates in clumps versus individuals. And a big thing to keep in mind, and what I'm going to say here, is we were just looking at trees up to 30 years old, but actually trees are growing faster when they're growing in clumps than they are when they're growing individually, both in height growth and in diameter growth. Up to a certain point, we found that if you have more than 7 trees per square meter, you end up actually reducing tree growth. But it does seem to be a benefit to growing in clumps for this initial period anyway. I don't think anybody would doubt that as you get trees larger, competition is going on and could slow down growth rates. But there may be a benefit to the clumping pattern, at least for the early stages of growth.
Great, thanks so much.
I just wanted to add on real quick, or just ask Malcolm if you're able to drop that paper into the chat. I know that there's probably a lot of interested parties on this webinar that would like to see that. I was going to search for it, but you probably know where it is better than I do.
Yeah, I'll see if I can figure out how to drop it in the chat.
Okay, so we're going to do this one differently because again, it's between two. So if you have an answer to this, feel free to pop in. The tendency to high severity fires will pauperize the soil's store of pyrocarbons, or SOMs, which hold water for regrowth. Is the addition of carbon to a soil beneficial?
So I will briefly answer in terms of, you know, there's this entire market in biochar. And so, you know, I don't have scientific studies on it. I'm sure others do, but there does seem to be benefits to adding, you know, biochar to soils. And so I will leave it there and see if anybody else wants to pick it up.
Going once, going twice.
Could be tested in our experimental network as a treatment, if anybody wants to try it.
Sounds like a research question. Okay, well then we're going to jump to the other one. So for large, high intensity mega fire areas where post-fire treatments are limited, what can we do? Areas with standing dead trees and understory regrowth. I'm thinking this is kind of a prioritization question, if there's anything to add about how do we prioritize these big areas?
I'm happy to start jumping into that one and then let others pick off. I mean, that is really the question of the day. That's why we're here. And I see that Rob typed in an answer, but I'm not going to go check his answer because I'm talking right now. But really, it is about prioritization. There's obviously spots that you're going to want to proactively do something there. And then there's spots that you're not going to be able to proactively do something there, or not without a Herculean effort and a lot of funding. And so that's where, you know, looking at your landscape, looking at where you can be successful, looking at what your suite of tools is and what your desired conditions are, and whether or not those tools get you there is, you know, a critical effort for this and other collaborative groups to go through. We've got a lot of science backing up some of the actions, and then there's still a lot of questions out there that need to be addressed, and that we will continue to learn things.
You know, I'll just add one thing here, and that is that, and it's kind of a reiterating what something that Dana mentioned, and I was appreciated that she mentioned it, and that is, in these areas where you don't do anything, in many cases, you're done there for a long time. You can't safely put crews in there, and I'm speaking from personal experience. It's really difficult to actually just put human beings in there after a while. So when you don't salvage, you have to understand you might be going through a long period where you just not even want to be in there, and it really does just limit your future. It limits your future decision space when you fail to salvage it. If you've got large trees, little stuff will come down pretty quick, but the bigger ones won't.
Great. Anything else to add on this idea?
Well, I know I'll add my 2 cents, even though I wasn't a speaker this morning. I know most of you, and I think Dana mentioned this, that the GTR 270 that, you know, a number of us on the panel and probably in the audience today worked on the post-fire framework for California, really does sort of get at this idea of prioritization and thinking about maybe where and why you should, you know, focus your efforts in particular places. So I, you know, encourage those of you that are interested in thinking a little bit more about that. I think that question came from Lester, and I think he's participated in some of those conversations around GTR 270. You know, think about that as a tool for sort of helping us triage these landscapes. And I think, you know, one of my questions to the panel is really this idea of prioritization, and just thinking, you know, over the past couple of years, these fires have gotten larger and larger. And, you know, we can't possibly reforest every, you know, square acre of these fires. And, you know, what are your recommendations on how we can think about where and why we would prioritize certain landscapes over another? And so I'll just throw that back out at you guys on, you know, from your work, your research and your monitoring efforts, or just your engagement and implementation, you know, what would be sort of one recommendation that you would have moving forward that I think would help, you know, the two collaborative groups and the forest plan for post-fire restoration in, say, a Caldor fire?
I guess, you know, in the context of my particular talk that I gave, it would suggest that we prioritize areas where we know we're going to be able to work with prescribed fire in the future. So, you know, across the landscape, you know, there spatially certain areas make sense, like, you know, whether it's because of their proximity to roads, or they're making logical burn units, or they're or because they're not close to communities, or you know, things like that, or they're on south facing slopes is another thing. I know we kind of think about avoiding south facing slopes in terms of being harsher conditions, but given the conditions under which we can do prescribed fires, logistically and from a permitting perspective, sometimes it's the south facing slopes that are where it's more achievable. So I guess in terms of triaging or prioritizing, under the context of my pyrosilviculture talk anyway, it would be thinking about like what areas you're going to be able to burn for all the different constraints that are involved with prescribed fire.
I guess I would make just the comment that we do have large areas that could be worked on, and that I think this creates opportunity to incorporate research into those projects. And you know, there are a lot of questions that need answering, and being able to get some of those projects on the ground as part of that work. Also, I would make a case for that.
And I think most of you that know me are not going to be surprised by my answer. But, you know, prioritizing one where we can be successful, where we can have the resources and tools to actually implement those treatments and wisely use both time and capacity and money to achieve restoring forest. And really in a way that considers how we are going to continue to live with fire. You know, there is hopefully no doubt among people in California any longer that the areas will burn again. And so how do we set ourselves up to retain what we're trying to restore as it does burn again? Some of those will be these easy locations, but as you know, I got the opportunity to learn on a subsequent fire, some of those hard areas to work are really important too, to that future fire strategy. And so we need to be putting that strategy into our actions and doing it in a time that is meaningful.
Hey, Stacy, this is Chuck. I had a question for Rob, and since I don't have access to the question, I was wondering if I could throw it in.
Let's make it a conversation. That sounds great. Go ahead.
Yeah, Rob, if I understood you correctly, it looked like the spring burning had higher scorch and mortality issues with the young trees, and versus the fall, which was kind of surprising to me from past burning experience. And I was wondering if you attribute that to the fact that the fuels are wetter, and so to get the in prescription to actually get the fire to take, you have to burn a hotter fire in the spring than you do in the fall when the fuels are drier throughout the area, and so that you can burn under different prescriptions, humidity, temperature wise.
Yeah, so a couple of things. I think in terms of the data that I showed, what those graphs were actually showing that in the fall versus spring study, the mortality was about the same. So fall mortality was 20%, spring mortality was 20%, but the spring burn didn't also have the fuel consumption that the fall burn had. But that being said, I have had spring burns where I have had very high mortality. When I kind of think about the mechanisms for that, there's a couple of things. You know, I've seen high pine mortality after spring burns because of interactions with bark beetles, so red turpentine beetles. Again, it's not consistent, you know, it's not every time, but I've seen that occur. And then if you look into the physiology, kind of the fire physiology research, there is this kind of mechanism where higher live fuel moisture makes leaves more susceptible to mortality, to ground damage. I think another important factor with spring burning is if we're burning in the daytime, we can have higher air temperatures, right? And so I've seen, again, it's not that's not like a spring thing that occurs, but like sometimes if we're burning in the spring under higher ambient temperatures, then it just doesn't take as much to scorch trees. So again, I don't want to kind of, those of you who have had success in the spring, or if that's your window, like do it, like burn when you can, as what I always say. But if you just know that with spring burning, in my experience and through my monitoring, I've had less consistency in the outcome in terms of mortality and fuel consumption.
Well, that's great. And I mean, it kind of lines up with actually where I think we want to be going to a large extent, because when we do spring burning, we end up having to babysit the fire sometimes throughout the whole fire season. So I think we're trending towards more fall burning. So I was just kind of surprised by what you were showing. So I appreciate the data.
We're going to continue with our panelists asking other panelists questions. Rob, I know you had a question for Martin. Would you feel comfortable asking that?
Yeah, sure. The Martin, your study reminded me of another study, I think from the 80s, Boone Kaufman. It looked at prescribed fires and found that they promoted tree form in black oak and more shrub form in tan oak. And I was wondering if you had any insights into, like, prescribed fire as a tool for promoting the tree form in black oak versus thinning the clumps. Like any insight onto kind of what the differences might be?
Actually, no. I don't really have any insight on that. It's an interesting question. I'm not sure.
Well, I guess if nothing else, it does kind of make the thinning make sense to me. Like I think with prescribed fire with Boone Kaufman, what he did was, I think he thinned clumps with prescribed fire, and that's what made kind of the tree form develop. And so it seems like you're doing the same thing.
So was he broadcast burning, or was he kind of like spot burning? How was he applying that?
It was broadcast burn. Yeah.
Broadcast. Okay.
Yeah.
And you know what ages? Or I mean, were they really young? Were they?
I don't remember. It was like these were post clear cut, so I think they were probably like 20. I don't know. My guess is like somewhere around 10 to 20 years, something like that.
Mm-hmm. Well, I guess that the one thing that does occur to me is that if you ran prescribed fire through there, especially when it was small, you might be able to nick off some of those stems. And like I said, if you leave some of them, then it's not going to resprout, so it's conceivable that you could do that, if it didn't get so hot that it just really completely cooked everything. So it would really be, my impression of black oak is it's really easy to top kill those guys. It doesn't seem to take much heat to like totally kill it, and you're set and you're back to sprouting again. So the difficult thing in my mind would be, can you do it in such a way that you just don't, it doesn't get so hot that it just totally top kills the whole thing.
Yeah, thanks. That sounds good.
We have a short one. Well, maybe I always guess it's short or not. This is for Jessica. It was in the chat, but what does the provenance test do? Like, could you tell us more about what that is and what it does?
Sure. So yeah, I saw that question too. So provenance tests are planted to see how different sources of trees perform in a common garden environment. So seeds are collected from, in some cases, the entire species range. I'll just give an example. We have established a test in valley oak, Quercus lobata, since we're talking oaks, where we collected from 674 different trees growing in 95 different collection locations across the entire species range. We brought all those acorns back to Placerville and germinated them in a greenhouse there. And then when they were 2 years old, they got planted out into 2 field sites, one at the Institute of Forest Genetics in Placerville and the other at the Chico Seed Orchard in Chico. And those trees have been growing for, they're 10 years old now. So what we've done then is measured their growth and performance every year to see how quickly the seeds are growing from different sources. And then also collecting other specific data. For example, we've been looking at bud burst and when leaves emerge in the spring onto these different trees. And it turns out that trees growing in Placerville burst bud about 2 weeks later than the trees growing in Chico. But then trees from warmer places leaf out sooner than trees from colder places. So we see both an effect of the environment they're growing in, the 2 different planting sites, and we see effects of where the trees came from in terms of how their timing of bud burst. And that's what these provenance tests allow us to do, is compare that performance from different locations, from different climates in a common garden in 1 or 2 planting sites. And we've been doing this for 100 years or so. So we have another test at IFG that was planted in 1938, which was an elevational transect of ponderosa pine, looking at pine trees growing from, I kid you not, the bottom of Folsom Lake up to Lake Tahoe. and growing them in common gardens at low, middle, and high elevations and seeing how their performance varies. So originally these were thought of from timber production and how to get the best timber production from these sites, but they do great tests of climate change as seedlings got moved to new climates. So that's the tool of the provenance test that we're using to look at how trees perform in different climates and make predictions about how a planting site might have a different future climate and how trees might perform in that future climate.
That was such a I learned so much from that answer. Thank you so much for explaining it in a way that I think everyone can follow. That's fascinating. Becky, I think you had a question for some folks.
Yeah, I definitely have a couple of questions. So I think, Malcolm, maybe this was in your talk. I should have also written down when the question came up because I can't quite remember, but I think probably all of you would likely have an answer to this. But I was thinking about, you know, I think one of the topics of conversation is prescribed burning in plantations, especially young plantations, but just thinking a little bit about, or whether or not we've looked at the trade-off between burning in prescribed in young stands versus mortality from a moderate or high severity wildfire. And I think I know the answer to this. Obviously, if we have high severity fire, those plantations are, you know, they're not going to be there. It's going to be 100% mortality. But I'm just trying to think of a way to show people, you know, how we can benefit from prescribed burning in these young stands versus the trade-off, which is, you know, completely losing them.
I think Rob's probably better prepared to answer this than I am. I do know that at least the context we were looking at both the wildfire and prescribed fire in stands where you have both regeneration understory and overstory trees. You can depend on a certain amount of regeneration mortality with either one of those treatments, a low intensity wildfire or prescribed fire, in the understory and the regeneration. And that, to my mind, is kind of what I'm just starting to see as we study more of these stands, is if you are looking at a low to moderate burn severity area, it's going to have really high natural recruitment regeneration rates. And you actually want to thin those stems out with some mortality. And so there's a benefit to actually having fire. The fire in these cases is not nearly as well controlled as what Rob's been working with, but it does seem to be pushing the stand in the right direction. The overstory mortality that you get really seems to be a function of kind of happenstance of, are there ladder fuels there? Are there big logs against some of these trees? And to my mind, that's a case of where if you really want to preserve certain either species or certain trees, there's a real value to going in with saws or with some kind of silvicultural precision that can surgically remove the risk to those very overstory trees that you want to hold on to. So I'll leave it with that. And Rob, I'm sure you'd have more to add than I do about this.
Just a couple of things. One is that, you know, I when I think of the role that prescribed fire in young stands might have in terms of protecting them from high severity fire, you know, I guess I'm thinking of the factor that the prescribed fire is going to have when fire weather is kind of, you know, in the moderate range. So because it might very well be that if the fire weather is extreme or if winds are extreme, we might very well get, you know, high severity effects in a young stand, even if it had been prescribed burn. So it's like, it's more kind of pushing the probability of the fire being lower in severity, but not like, you know, but not to say that we are going to like absolutely, you know, achieve low severity. And then the other thing that the question reminded me was the research that Zhangwei Zhang did on a backburn that was done, a backburn during a wildfire that was done through a study, a level of density study, where I'm pretty sure they found that the higher density treatments did not have super high mortality. So this is a backburn that occurred overnight during a wildfire. And the higher density, like this was a study, so it's kind of all controlled. And the higher density treatments did not have any higher mortality. And I've thought about that study, and again, getting back to the site preparation, like I don't, that was a controlled experiment designed for a silviculture kind of outcome, but it was site prepared before it was planted. And I think that kind of robustness of planting of tree density that you can see during wildfires, it makes a difference if it was site prepared or not, or if vegetation control occurred or not. Like I just think that kind of the capacity for higher density plantations to endure wildfires has a lot to do with reforestation practices, and not necessarily, it's not necessarily just density. It has a lot to do about previous reforestation practices, I think.
Okay, anything else on that? Okay, so this question is, I know that YSS and ACCG have recommended varying the densities and spatial arrangements in post-fire restoration. Has there been any study of the results of replanting that has followed those recommendations?
I didn't quite understand the last part of that question. Could you state it again, please?
I think it's about monitoring, right? So there's these recommendations about replanting in these different ways, but has there been any results from how those replantings have worked out that follow the new recommendations?
I'll take a first stab at that, but I would also defer to Dana, who I think is going to know this better than I do. But there have not been many comparison studies that I'm aware of, at least when I was first writing a paper about this. I could find very little clump versus regular spacing comparisons, unless you went to the European literature around the Mediterranean, and then you're dealing with oaks often. Very difficult to translate those results. The only thing I know of is this recent paper that Hannah did looking at the growth rates, where you have trees growing by themselves without any adjacent tree versus growing in clumps, and then comparing the rates, the growth rates between those two. And as I mentioned, at least you appear to get better growth rates for the first 30 years. But I don't know of a trial done in the Western US and conifer forests where they explicitly planted those things and then compared side by side comparison rates. We have an experiment underway at the Caldor Fire doing that, and the initial response is that the trees and clumps are growing better and keeping the brush at bay versus the individual trees just get swallowed by these huge shrub responses. But Dana, I'll turn it over to you or anyone else who wants to jump in at this point.
I would typically default to Malcolm on that one. There is a study currently being implemented on the King Fire that will be looking at that. But just like the Caldor Fire study, they're fairly new, and I don't expect anything out of that King Fire one for quite a while. Ryan Tompkins with the UC Cooperative has some plots on the Moonlight Fire and some data there. There's nothing published on it, but that's another one that's out there that may produce something in the future.
Yeah, and I will just add, since this seminar is being hosted by partially hosted by the ACCG, the monitoring work group was working within the Power Fire to look at some variable density planting. And so we do have intentions of continuing to monitor that. Sadly, we, because of a whole host of reasons, those sites haven't been planted yet. So I think we're all sort of in the same sort of phase with an understanding, cluster planting versus individual tree planting, and that we're still learning. And I really feel like, we do have some opportunities, just talking within this forum here and thinking about, how we might plan restoration in other fires, e.g. the Caldor Fire. We may want to experiment and think a little bit about trying to understand some of these lingering questions that I think we all still have.
With that, I think we are, one more call, I guess, if anybody does have another question they want to throw out there. If any of the panelists have a question for the other panelists, this is the chance.
Yeah, I think I would encourage those of us that are on panelists Zoom that can't put questions in the Q&A to ask them now. There may be some questions out there.
I had one for Malcolm. When you were talking about the prescribed burning in Power Fire and the trees within the clump persisting, whereas the ones on the outside of the clump were killed, I was curious about the timing of burns. I wasn't super surprised because typically our prescribed burns are when fuel moistures, live fuel moistures are going to be higher, but just wanted to kind of get your input on the time of year that was burning.
Yeah, well, consistent with, I think, what you're suggesting you expect is most of the prescribed burns, I think 3 of the 4 that we were working with were lit during the winter, during dry periods. And so the fuel moistures were down quite low and the fire carried really well, but the relative humidity was up and the temperatures were down, and the fire, you know, was much more that kind of level where it's kind of slowly moving through the understory and you're getting good consumption, but you're not really faced with, you know, 10-foot flames or even 6-foot flames. It was all because of the low temperatures and the high relative humidity that kept the fire just kind of moving along. And my guess is that would have contributed pretty significantly the fact that you'd char and kill the outside trees of the donut, but that the ones in the center came through pretty well.
If I can just add to that, Malcolm, I've observed that quite frequently, actually, when we have a high density patch of saplings and then do low intensity prescribed fire, I've seen that donut shape outcome, or the kind of feathering of the edges occur. I've seen it on Kings Canyon National Park, where they burn giant sequoia patches, kind of have that same spatial pattern. So just kind of a verification for like it's. I'm actually not totally surprised, actually, from what I've seen, at least with the prescribed fire.
Well, I have one more question if there are no other takers out there in the webinar world or on the panelists. So I know a couple of weeks ago, maybe a month ago, the Southern Sierra had a session that was just looking at, you know, climate smart reforestation techniques. And I just wanted to open up to, and we've kind of talked about it a little today, and probably all of your talks it was touched on, just thinking about, you know, what are some climate smart reforestation techniques that you would recommend that we should incorporate within our post-fire restoration plans?
Well, I'll take the bait first, and then I'm looking at some other people here who are probably more qualified to talk about this than me, but several of us were at that conference in Visalia. And this is partial personal opinion as well as just some of these studies we've been working on, but I do think that the conditions we're producing after these high severity fires are really suggesting that we need to be questioning just about everything we're doing in terms of reforestation, because the shrub covers that you get sometimes following these high severity fires are so intense that the only people who are really succeeding at planting those things either on a regular spacing or without any clump patterns is SPI with heavy use of herbicides. And I think you have to deal with the shrub problem and the shrub cover. And if that's not an option going forward on federal lands, and I think there's definitely some debate as to whether you can apply herbicides as frequently as SPI does, I think there's value in at least investigating this clumping pattern and seeing whether it can bias something. It does seem like a profligate use of tree seedlings when we have a very limited supply of them, and you're going to shove a bunch of them together and then burn up some of them on the edges as you put fire in the thing. But on the other hand, it clearly seems to build a better fire resilience into these young plantations than even spacing does. And the clumping of the seedlings keeps the shrubs at bay so that the trees can continue to grow. So I'll turn it over to anybody else at this point. But
I don't know if anybody else on the panel here other than myself and Malcolm were there. a lot of the conversations there also focused around, I guess Sue was also there, but she's not on screen, but she could also definitely speak up on her input from it. A lot of the conversation focused on prioritizing and putting your resources and efforts into where you can be successful and where you can meet objectives, and really kind of looking at what those objectives are. Use of prescribed fire and really taking advantage of remaining forest cover in these fires has been a continuous identified opportunity that really needs to be leveraged. It's a lot easier to keep trees on the landscape. It doesn't seem so with the fires burning, but it's a lot easier to keep trees than to reestablish them and have to start over to get to where we want to be. And so using those as anchor points, really the work that Jessica is doing about what trees might be best going forward is going to be really pivotal to how we think about this. Is it the trees that are there, or is it going to be something else to actually have a forest in the future? And there's a lot of people who are interested in helping. That was another component that I think really stood out, that our current systems may not make space for everybody who wants to help, but how do we actually build that in and integrate society and the public and others into these reforestation landscapes? Because especially on National Forest System lands, it's the public who's paying for it, and it needs to be engaged and enthused about having a forest for the future if it's something that's going to successfully be done.
I'll add one more thing to what Malcolm mentioned a minute ago, and I've had recent conversations with Ed Frederickson and other people at SPI. And one of the interesting things that I've gotten from those conversations is that in some instances now, the way they're tending to apply herbicides is more thoughtful about it as a site prep as opposed to a release treatment, and finding that because some of the new formulations and not having to worry about damaging your seedlings, that they can sometimes get away with, they hit it once, site prep, and they're done. They may not need to come back after that. So there's that little wrinkle too, that they're beginning to find that can be successful, just a one-time shot before you plant, and then you're done.
I was not able to be at the meeting in Visalia because I was at the North American Forest Genetics Society meeting. So I'm sorry I missed it, but I believe the postdoc Joe, whose work put together the cast tool, was there. And I do think that thinking about the adaptation of the seeds and what climates the seeds and seedlings would be adapted to, and what climate the site that you're planting is going to have, is I think going to be key going forward.
My 2 cents on kind of shrub management that I tend to think about is there's the SPI approach of kind of the higher intensity shrub control, but like it doesn't mean that we have to, and that could be, I was saying in my talk I like that from a burnability perspective, but my rule of thumb that I tend to think about is it's like, I'm okay with 30% shrub cover, at 15 years, like that's burnable as well. And so, it doesn't mean that we have to have 0% cover, but if we get a more than 30% cover, it does make it really hard in my experience. And so I think I'm agreeing with Martin essentially in that, there's a level of application that could be done to minimize the application itself, but still get an acceptable shrub cover outcome in the future. And we don't have to target, probably shouldn't be targeting 0% shrub cover, but 30% of cover is kind of generally my rule of thumb in terms of like what's still burnable, but still has a significant amount of shrub cover.
I would second that. I mean, the reconstruction studies I've seen of historical shrub levels are some are usually around that level. And I also think there's an advantage with shrubs as sometimes both an accelerant and heat sink when you are burning some of these stands, although Rob would know more about this than myself, but at least I've seen some of that at Tea Kettle and the burns we do, where the shrubs sometimes accelerate the fire and other times they don't.
Yeah, and I'll say a couple of things before we get started, and also just in case others have joined this afternoon that weren't on this morning. Becky Estes, I'm the Central Sierra Province ecologist with the Forest Service. And just to preface the afternoon talks, most of the ones from this morning were focused on vegetation management. And this afternoon will be focused more on wildlife management and post-fire landscapes. We'll have a break in the afternoon, and then we'll also have a panel discussion. So if we have time for questions after each of the talks, we'll address them then. But if not, like Stacey mentioned, try to put who, if the question is addressed to a specific panelist, so we can address it in the discussion period. That will be at the end. So the first speaker this afternoon is Helen Loffland. She's with the Institute of Bird Populations, and she'll be sharing some of the work that she's been doing on Western bumblebee distribution and management in the Central Sierra Nevada. So Helen, I'll pass it over to you.
Looks like you're still muted, Helen.
Thank you. Let me see, share my screen and put it into slideshow. Okay, that look
That
right
looks great.
to everybody? Okay. So yeah, like Becky mentioned, I'm going to start us off this afternoon for that post-lunch lull. Hopefully I don't lose anybody to a little nap. I am with the Institute for Bird Populations, and I'm Meadow specialist there, but I've actually worked a lot as well in post-fire landscapes here in Amador County where I live. And I've been working with Becky and others on the ACCG Monitoring team for a few years now to explore some of the wildlife and vegetation related questions that our monitoring group has been asking. But today I'm going to talk about bumblebees. Let me move my screen a little bit around. Okay. And I think my title is also different from what's on the agenda, but it's close enough. So I just want to give you a background of what I'm going to talk about today, sort of the why bumblebees, overview in general of our bumblebee monitoring program, our methods briefly, and then get really just mostly into some of the results of some of the bumblebee habitat selection work we've done, and also bumblebee response to some of the post-fire management that's been happening primarily in the power fire, but also some of these results will come from the Fred's fire, which is over also on the Highway 50 corridor within the range of the SOFAR people. And then some kind of applications of results. And so this first slide is to, image on this slide is to remind me talk about why are we even looking at bumblebees? Why is this something that was of interest for our ACCG monitoring area? And this is a slide of a Western bumblebee. This species back probably in the 1930s, 40s was still considered the most common bumblebee species in the Western states. It has declined rapidly, and at the same time that it was added to the Forest Service sensitive species list, it was the same week that the Forest Service also received mitigation dollars to look at the power fire and to start some funding to start restoration within the power fire area. And so one of the questions that our partners at the Forest Service brought to us was, do we have Western bumblebees here? Because we're supposed to be managing for them. And if we do have them here, how might the post-fire management affect them? And so that was kind of a big unknown. And so that's kind of how we got to this place. Okay, and so this slide's just to kind of take that step of like, actually this project that I'm going to talk about really was what started Institute for Bird Populations into sort of a broader pollinator program and bumblebee work. And so this map just kind of shows you the range of the projects where we've been working with bumblebee surveys since about 2015. And those first ones down the south, these red dots in the south, this is Fred's fire and the power fire on the El Dorado. And that's what I'm going to talk about today. You can see we've also been looking for Western bumblebee and at other bumblebee species at project areas through much of the Sierra Nevada and points north. And so with all of these, we use basically the same protocol, and that's to look at, one, to look for Western bumblebee, but also just to record that the abundance and diversity of bumblebee species that we find out there in the landscape, and look at what sorts of plants they're associated with for foraging and general habitat use patterns. But then really a big part of it is to provide some guidance for land managers. And specifically this project that I'm going to talk about today was looking at sort of direct and indirect impacts of herbicide, striped fire, all kinds of thinning, mastication, those sorts of treatments that were getting ready to happen within the power fire area as the Forest Service kind of geared up to replant and manage that landscape post-fire. And so just really briefly, so you kind of have a sense of how we're monitoring for bumblebees, we set up these 20-meter circular plots that are randomly distributed across the fire areas, in this case, fire areas. And those plots are surveyed twice a summer. It's a 16-minute active search where we're netting bumblebees. We're putting them in a little plastic vial and cooling them in an ice chest so that we can identify them once they've cooled down. And then we're also recording plant species that they were foraging on when we captured them. So either collecting pollen or nectar from some sort of floral resource. So we record what plants are actually blooming in that 20-meter circular plot when we're doing the surveys, and then also sort of that standard vegetative information about the plot. How much tree cover, what species of trees, how much shrub cover, downed wood, those sorts of things. Let's see, I think there was, and then what I didn't come back to was, so we put the bee in the vial after we finished that active search, and the bees have chilled, we're able to take them back out. We take photographs to document the species. Luckily, most bumblebees are pretty readily identified just using like a hand lens or even with the naked eye. So once they warm up, they're off to do their thing again. So this, and I apologize if I'm running through this a little bit quick. I kind of want to cover a couple of different aspects of this project, because it occurred, and what I didn't mention on the last slide is that we collected bumblebee data from 2015 through 2019. And so the first 3 years at both the Fred's fire and the power fire. And then the last 2 years were just on the power fire. And so this slide is showing a map of the power fire. All the little, both kind of purple dots and the tiny white dots are the locations of all of the bumblebee plots that we had. And this is just a slide showing 2018 results. So you can kind of see larger purple dots. We had more captures in those at those sites, whereas the tiny little white dots meant it was a plot that we surveyed and didn't find any bumblebees. And then the other polygons there within the fire perimeter were the planned treatments. So things like brush cut, herbicide, what's that, mechanical pile, I guess is what that says. Anyhow, so this is just to get a sense of it. We had plots both, we randomly placed plots within areas that were planned for treatment, as well as outside of those treatment areas that we would have controls as well. And so, like I said, there were sort of two parts of this project. One, just to look at what bumblebees are out there, what plants do they like, what vegetation systems do they like to occur in, but then also to see if we could get a signature on how these different treatments might impact bumblebees. So the first thing that we saw over that 5-year period was that bumblebee abundance really varied a lot by year. And so this graph is just showing the capture rate, like the average number of bees caught per survey visit. And so it's adjusted for effort. So you really can look across these years and see that, like 2016, there was a lot of bumblebees out there. 2017, not so much. And so, you know, that's kind of the first thing to think about moving forward, is that there's a lot of variability for these taxa. And then this slide is just showing what bumblebee species were out there and the proportions. And so the brown part of the pie chart is Bombus vosnesenskii. That's our most common species. It's the most common species, I think, in all of our study areas throughout the Sierra Nevada. And so you can see it takes up a big part of what we're looking at every year, but there some of the less common species we did see changes over time in their abundance as
KL.
Well, is the which is the most common one, and that we're going to, you'll see that come up quite a bit on the slides. Okay, so this was just the first part of the initial project, the first 3 years of the study, just looking at some of that really basic, like overstory cover and herbaceous cover, and how that affected bumblebee occupancy. And so kind of the first thing to notice is like the shrub cover was not a really big driver for any of these species. However, for 3 of our species, overstory cover, as overstory cover of conifers primarily increased, the likelihood of those bumblebee species being there decreased quite a bit. And on the far right here, the most important thing probably is this herbaceous cover was really the important factor for almost all of our species, and it really drove how many bumblebees we captured, which makes sense because herbaceous cover typically means you've got a lot of different wildflowers out there, and so bumblebees are really, their abundance is being driven by the presence of a lot of those wildflowers. And this is the same part of it. We just so that you know that a lot of these species actually do increase as you went up in elevation, which is normal for bumblebees. They're a species that evolved under sort of in the northern hemisphere and are found more variety in northern latitudes and higher elevations. We had pretty similar occupancy in both upland and riparian areas, so really anywhere you had flowering plants. And then this right-hand graph just showing you that for that most common bumblebee, Vossisinsky, actually the amount of bare clover cover, which is one of those target shrub species that we think about in post-fire management, and trying to manage it for tree planting or reducing future fire risk. So that was actually a big predictor. We found that Vossisinsky, the most common, really used that shrub a lot and was sort of associated with just its presence, even if it wasn't in bloom. Okay, and then this is going back to looking at not just where we found bumblebees, which was those last slides. This is what plants were they actually collecting pollen or nectar on when we captured them, and looking at that use of those plants relative to the availability of those plants across the landscape we were surveying. So dots above this dotted line means that they selected that plant and used it more than you would expect just based on the availability of the plant. Dots below the dotted line are those that they use less than you would expect based on the availability. So again, bare clover showing up here. It was a plant that was used a lot as a foraging resource, but also some herbaceous plants like Phacelia, bull thistle, which is an introduced species. We can talk about that. As well as some others, stick seed. But interestingly, down here, whitethorn, and I actually think this dot to the left of it directly, although it's not labeled, was the earbrush ceanothus. And so those two ceanothus that we really see a lot in this fire area, and that can be an issue for, as we've heard earlier this morning with prescribed fire and replanting and competition with trees, those two actually were not selected. They were used less than you would expect based on those plants in the landscape. If you've been out in one of those fields, it's a whitethorn, it's all in bloom, you might think you'd have a lot of, we do have a lot of pollinators on them, but not bumblebees. They weren't selecting that plant species as one of their preferred. And this, I'll just go through this quickly. This is just showing how plant use kind of changed, so that when bare clover was abundant early on, that was what was being used. But as bare clover flowers became less abundant, bumblebees were switching to other plant species. And that's just the importance of that temporal heterogeneity of plants for these bumblebees to be using. They need something that's going to keep them going through the whole season. just some photos of some of these nice plants. I've made you look at a bunch of graphs in a row. Okay, so now I get to the part where we're trying to really look at how did bumblebees respond to some of these different treatments that were happening on the landscape. This is where we talk about the challenges of real world versus like what we thought we hoped would happen with the study design. And the first thing that kind of came into play here, this is that I showed you this graph already. This is on the left, the 5 years of study. When we started the plan for all involved was that most of these treatments would really start occurring around 2016 and early 2017 in the power fire. There was a lot of delays. And so really what ended up happening is, with the exception of some plots on the Fred's fire, pretty much everything from 2015 to midway through 2018 was basically baseline data. We had no treatments happening yet in any of the areas that we were working in the power fire. And so all the treatments happened basically that we saw between 2018 and into 2019. So as a study design, when you want to look at the effects maybe 1, 2, 3 years out from a treatment, we had a problem because we don't have a lot of post-treatment data. We really have that one season 2019 to look at post-treatment data. And then other things that we ran into were, because this wasn't a controlled experiment, we really were just working within the confines of, we knew where treatments were supposed to happen, but all those treatments were being managed through, other contractors, different parts of the agency. And so we're really kind of just hoping to catch everything at a time that we could. And so there's just some complications with that, but it's all good. But I wanted to show that kind of where we ended, there was some pretty complicated treatment histories that we ended up seeing in some of these areas where we had, and the way to read, you don't need to read this. It's more just to show you that we had a lot of different treatments, and it ended up affecting some of our sample sizes over the column that's second from the right. You'll see that, for a lot of these, we maybe only had 15, 16 plots that ended up being treated with this same combination of treatments, where we had plenty of control sites. And so, that definitely kind of affected our ability to feel really confident in getting really good treatment response. But there was some stuff that did come out, and so I'm going to share that with you. So this is just looking at, these are the plots that I mentioned on the Fred's fire that actually were treated with herbicide during 2000, or just prior to 2016. It was in 2016, but our surveys came post, like a month after herbicide treatment had occurred for the most part. And so each of these blocks is a different bumblebee species. And we're comparing the treated plots, the occupancy of bumblebees and the treated plots versus the control plots or untreated plots. And so if dots are below the dotted line, that means that there was a decrease. If the dot is above the dotted line, like here for Van Dyckii, that means there was a slight increase in the treated plot relative to the control plot. And so we saw pretty, for like these 3 species here, Mixtus bifarius, and I can't see what that one is. I think it's probably, well, whatever that one is, I can't read it under the chart. We didn't see a huge effect from those herbicide treatments in both in year 1 or year 2 post-treatment. But for our most common species, these 3 here on this side, what we saw was that in the year immediately following, or the year of the treatment, basically, so that same growing season as the treatment occurred, we saw pretty major declines in the bumblebee abundance or likelihood of occupancy. But then the year after treatment, where there'd been a whole growing season, and now we're looking at the following growing season, numbers really came back pretty close to what they were at the control sites. So, it's interesting to see. I mean, and it makes sense that the application of herbicide is going to reduce some of the floral resources, so probably the bees. But if there's if you have a lot of non-target floral resources out there, like the herbaceous vegetation, that's going to potentially come back even bigger than it was the first year. This is also just looking at at, this is on the Power Fire, but we only really have 1 year of post-treatment data. And we had 2 different types of treatments. You'll see at the bottom, the M means it was just mechanical treatment. And the M plus C means it was both mechanical and chemical treatment occurred over the course of the project, but we're looking just at that first year afterwards. Similar thing, we have, very small, probably insignificant changes in occupancy for a lot of these with both treatment types, except for this interesting, this Californicus bumblebee, we see a slight increase after the mechanical and chemical treatment. And then, kind of as we saw before with these same 3 species here that are our most abundant, we saw more declines that were greater when we added the chemical component to just the mechanical treatment to remove brush. And then this was just one where we put everything together, prescribed fire, mechanical treatment, herbicide, and just looked for each of the species, whether there was a signature of a change relative to the control sites. And it's all still centered pretty closely around the, to the 0, which means there was not a lot of real obvious effect, with the exception of Vosnesinskii, which showed a pretty marked decline in occupancy. And of course, this too, remember, is the species that was highly associated with bear clover as well. So that, that might be part of that explanation, but it's also our most common species with the best sample size. So, there's a lot going on there. So really, I was supposed to come up with a few bullet points for management, but this is really not a few, and they're not bullets, so I apologize for that. But and actually, one thing I forgot to mention just now is this first bullet. So Western bumblebees, sensitive species. We know they're in severe decline. We didn't find a single one on the El Dorado study sites, and in fact, on all of our Sierra and Northern California projects, we've only found 5 Western bumblebees out of about 12,000 captures. And so, yeah, they're definitely in decline for going from the most common to not occurring in our project areas. But so that there's, I guess that's helpful, and from a management standpoint, and knowing that for right now, we don't think that that's a sensitive species that the Forest Service is needing to particularly manage for, at least for direct impacts on the El Dorado. But the other thing that, by looking at all the bumblebees out there too, we feel like we can use other bumblebee species a bit as a proxy to develop just general management recommendations for places where we do end up finding Western bumblebees, or just to promote pollinator health in general. One of the first takeaways is that bumblebees were selecting sites that had high floral diversity and low tree cover. So that, that actually fits in pretty well with a lot of the types of management that we're talking about here in terms of, post-fire and managing for maybe lower stalking rates to lower future wildfire risk, things like that. The bees like places where there's lots of flowers, and so having the sunlight hit the forest floor will often provide that. We did find that bumblebees have definite plant preferences, and so as we develop that more, that's information that can be used in seed mixes for post-fire restoration or other types of restoration. It's a really easy win-win to put some of these important plants into restoration mixes and really doing some good for some of these pollinators that we're thinking about. Like I mentioned, only one of the brush species, bear clover, that we're typically thinking about and treating in our forestry practices was being significantly selected by bumblebees for foraging. So I think just keeping that in mind too can help us understand, where and how much, how those brush species are impacting bumblebees. And then we saw that herbicide treatments, and then to a lesser degree, some of the mechanical treatments did result in a decreased bumblebee occupancy in that first post-treatment growing season, but that occupancy really rebounded pretty quickly. Would have been nice to have been able to follow that out a little bit further and see, over more different treatment rounds, but we still did see that, and it was a pretty good signature. One thing too that I guess I didn't really mention is that we did, although we saw declines in bumblebees in these treated sites, we did see bumblebees using sites that had recently been sprayed, and so there's been some concern because bumblebees have shown risks of, if they're directly sprayed, the surfactants within herbicides do cause high rates of mortality in bumblebees. So, we did see that they use these sites after spraying, so that there is some level of direct risk. But presumably, that does go away once the herbicides are dry. Direct and indirect impacts to both the vegetation and the bees, and then the bees thereafter, can be reduced if we try to use some of these herbicide treatments or other treatments before or after that peak bloom period, so that we're not treating them when the greatest number of the pollinators are on them. And then two, remembering that to the degree possible, selective treatment of those target shrubs or the target locations where we're trying to reduce, say, competition with trees or prepping a site, and of really trying to avoid spraying or otherwise, removing that herbaceous vegetation where we can, really will go a long way with bumblebees and a lot of the other pollinators to in that habitat. And I think that kind of brings back to what we were just talking about before lunch, that maybe, trying to maintain that 30%, not trying to go for zero on the shrub cover, but looking at something, understanding that the places where we're going to need to manage to reduce shrub cover, but knowing that it does still play a role. And I think, yeah, that's it. I just put the number of the papers that we've worked on related to the Power Fire, as well as some of the other projects and the Moonlight Fire, are on this webpage, so you can check those out if you're interested. And I just wanted to list the many, many, many partners that we've had on all of these different bumblebee projects throughout the Sierra Nevada, but especially the El Dorado, who's really supported this work here in Amador County. And I think that's it.
Excellent. Thank you so much, Helen. Very informative. So we don't have time for questions right now, so please save your questions for the discussion period. And we'll move on to our next speaker, which is Alyssa Fogg, who's from Point Blue, and she's going to be talking about monitoring avian species in the Power Fire, ecological implications for post-fire restoration. So Alyssa, if you can turn your camera on and get your presentation loaded.
Yeah, can you all hear me okay?
Yep, can hear you just fine.
Okay, and you're looking at my presentation, presenting?
Yep, you're good to go.
Okay. I'm going to talk about some of the effects of the Power Fire herbicide treatments on the early cereal forest bird community. First, I just want to start with, I feel like most of us in the audience know this, but just, want to be clear, what is complex early cereal forest? And so this habitat type results from disturbance, and fires are most common disturbance agent out west, but you can have things like windfall, hurricanes, insect outbreaks can also cause disturbance and these early cereal forest conditions. And some of these habitat components to look for include snags, standing dead trees, downed logs, diverse herbaceous layer, shrubs, and also the regenerating young conifers, and the broadleaf tree species like dogwood and hazelnut and oaks. So the bird community reliant on this vegetation structure and resources. These species nest and forage in the shrubs. They're attracted to the insects that are attracted to the flowers, and they also eat the seeds of these different species. So why do we care about early cereal forest in the bird community associated with it? This older burned areas, they're extremely valuable for birds. And we know through previous monitoring, my colleague at Point Blue, Jay Roberts, and I and Ryan Burnett had a paper where we looked at years since disturbance. So fire disturbance, primarily low severity fire, moderate and high severity fire, and also mechanical treatments across the Sierra. And the figure on the left shows the bird diversity in relation to, let me see if I can figure out how to do my pointer. I don't think I know how. Anyway, in relation to undisturbed, dense and open forests. So if you look all the way to the left on the y-axis, the undisturbed forest is down the single line over like where the 0 is, the single dot has some of the lowest diversity in comparison to moderate and high severity fire. And this peak actually occurs in that habitat type around 12, 13 years post-fire. And then in terms of abundance, that's the figure on the right, number of individuals increases with time at those moderate and high severity locations. And we modeled out to 20 years. So, I mean, you know, that trend could hold. And we found, just as a side note, all the disturbance types had higher diversity than undisturbed open or dense forest any year since disturbance. So how does post-fire management affect the bird community, and what do these different management techniques look like? So management in the Sierras, we've all seen, typically on, you know, varies across landowner and land use types. And on Forest Service land, typically portions of the burned areas, they're salvaged, remove the standing snags, chipping the smaller material. And then the lands are treated to reduce shrub herbaceous competition through, you know, could be herbicides, could be grubbing, and then they're replanted with conifers. And on private land, usually any burn biomass is removed. You know, it has a bit more aggressive shrub control and then replanted with conifers. And generally few to no shrubs or hardwoods are present. And herbicides may be used annually to reduce any competition with conifer growth. So the Power Fire, which burned in 2004 in the down in Amador Ranger District on the El Dorado, had a whole suite of post-fire management prescriptions, and some areas were left to regenerate naturally, some were salvaged, you know, all kinds of things happen. So the El Dorado was really interested in bird populations in burned areas, and we worked together to collect baseline bird and vegetation data from 2014 to 2016. And then much of this research has been highlighted in previous reports, publications. I can always send you those publications. And then in 2017, the forest proposed the Power Fire Reforestation project. These are mostly centered around the mechanical and herbicide treatments with replanting. So we had this great baseline data set of bird data at 138 locations. So we went out and resurveyed all those locations after the treatments took place. And we have 2 years of post-treatment data. So our monitoring data encompasses 10 to 16 years post-fire, which should represent the height of bird diversity and see our increasing trends in abundance according to our disturbance type paper in the journal that I showed you earlier. So the reforestation treatments had the goal of accelerating late cereal forest in Power Fire area. And they were proposed to take place across about 3,500 acres. So this is really rough GIS, about 65% of the complex early cereal forest habitat on the US Forest Service owned fire area. And these treatments included herbicide application, foliar application to whitethorn ceanothus, bear clover, grasses, other herbaceous vegetation. And the deerbrush ceanothus was actually mechanically removed, so chainsawed, left on the ground, and then herbicides were applied to inhibit sprouting. So the timing, they were applied during spring, summer 2018, and with some limited follow-up applications in 2019. So we didn't survey that season. We went back in 2019 and 2020 to do the post-treatment surveys. So just here's a map of the reforestation treatments overlaid with our survey locations are those black points. The green areas are where deerbrush ceanothus was cut using chainsaw and then later treated. And then the red areas were the foliar application herbicide only to mostly whitethorn ceanothus, but also bear clover and grasses. And then there are some yellow areas with dozer and piling treatments, which we didn't analyze. We had a few points in those areas, but we had pretty small sample sizes. So in all, we had 31 locations with 20 to 100% of the area within 50-meter radius of the point that were treated with herbicides. It's our sample size. So just here's a few pictures so that you can kind of envision these treatments if you haven't been out there, and hopefully some of you will head out there tomorrow. Here's a before after photo of the deer brush chainsaw treatments with herbicide follow-up. You can see the oaks and young conifers in the background, but the deer brush was cut and left on the ground. And then here's another before after photo showing herbicide application to the whitethorn, ceanothus, and greenleaf manzanita. And in those areas, the dead shrubs structure were left standing. Just quick, our survey methods, we completed 5-minute avian point count surveys. We counted all species, all birds seen and heard. We surveyed 1 to 2 times during the nesting season. And this was for 3 years prior to treatment and then 2 years post-treatment. We also collected vegetation data before and after treatments. So live shrub cover, dead shrub cover, young conifers, these are less than 16 feet tall, and then mature conifer cover as well. For our analysis, we focused on a suite of species common, to some extent also reliant on complex early cereal forest conditions. And these species, I'm going to start with the top left and go down. We have lazuli bunting, spotted towhee, green-tailed towhee, fox sparrow, yellow warbler, Nashville warbler, McGillivray's warbler, and then dusky flycatcher, house wren, and mountain quail. And we had a sample size of 31 treated points, and we identified 53 control locations out of our sample. We tried to pair them best we could. So those controls burned at moderate and high severity, and they didn't have any treatment within 100 meters of the point center. We used a mixed effects abundance modeling, where we estimated abundance and included some different habitat variables just to help fit the models. And we had a binary covariate for treatment. And then we used a ANOVA hypothesis test to compare time treatment and then the time treatment interaction effect to see if there was a different response before and after based on if it was treated or not. So here's some results, just starting with the vegetation data. These box plots show control and then pre-treatment and then the herbicide points. So so the control and pre-treatment are before any of the treatments took place, and then at the herbicide points, and these are also, they include both herbicide treatments, are in that post-treatment time period. And the y-axis shows percent cover estimated within 50 meters of the point center. So the take home on this, we'll look at the first one in the upper left, live shrub cover, is the pre-treatment points actually started out with higher shrub cover, which kind of makes sense from a management standpoint. But then it was greatly reduced post-treatment. And then we could see in the upper right, dead shrub cover, we saw a big increase. Those are like the shrub skeletons still standing. So they actually still provide some structure, but they don't have, any live leaves on them. That greatly increased. And now down in the bottom left are young conifer covers. So these are like the young regenerating conifers, was similar among treatments in years. And then as was the mature conifer cover as well, both fairly low. So here's the results for abundance of the whole guild of the complex early cereal forest birds. That's the figure on the top. And then the one on the bottom is guild richness, which is number of species, average number of species per point within a 75-meter radius plot. So the x-axis on top shows that number of birds, and the control lines are in blue, the herbicide treated ones are in that green. And the black lines show kind of the before and after when treatment occurred in 2018. So the take home is before treatment, abundance and richness was 15% higher in the pre-treatment locations. So these, may have been representing higher quality habitat even compared to those control locations. So however, after treatments, abundance was 48% higher at control locations, and the number of species was 66% higher at controls. And these overall declining trends we see likely reflect climate and weather patterns. And our data, we have a big monitoring program across the whole Sierra Cascades. It actually showed a sharp increase in bird abundance during the 2014-16 drought, and then it began to decline. So these declines are still concerning, but they likely have to do with bigger patterns than what was going on in Power Fire. So looking at individual species, none showed a positive treatment time interaction. And 5 out of the 10 of these early cereal forest species had significant negative treatment time interactions, which means they declined at the treated sites at a larger magnitude than at the controls. And these included fox sparrow, lazuli bunting, McGillivray's warbler, yellow warbler, and mountain quail. Several species show quite a bit higher abundance at the pre-treatment locations, like I said, potentially reflecting that higher quality habitat. And in some cases, especially with the warblers, these birds, they were nearly absent at treated points where they continued to be present at controls after the treatments occurred. And some of these species show significant declining trends in the Sierra Nevada breeding bird surveys, including fox sparrow and yellow warbler. So this is kind of a heavy duty slide, and I didn't plan on showing it, but I did want to mention that the abundance models can shed light on the mechanisms of the negative or lack of an herbicide response. So I highlighted shrub cover and the covariate responses in yellow. And you can see some of the ones like fox sparrow had one of the biggest declines, and it had, a highly significant response to shrub cover. And it was positive for 5 species, and young conifers as well was positive for 2 species. And then the treated covariate was negative for all the species except for green-tailed towhee. So in summary, we saw significant declines in early cereal species abundance and richness at treated points compared to controls. We weren't able to test for immediate effects from the herbicides, including any toxicity or decline in insect prey. We weren't on the ground during that time that the treatments were happening. So the abundance models indicate reduction in shrub cover likely drove those declines in these early cereal species. And these results, they concur with other studies. They're mainly from managed forests across the Pacific Northwest and Canada. And I have not come across a study looking at herbicide effects on birds, at least in post-fire areas. So the shrub nesters and foliage gleaners declined in these areas, whereas in general, many early cereal forest birds are declining due to a lack of habitat. So shrub and hardwood retention has been shown to mitigate for negative effects, and it could be something that we can experiment with. And if herbicides are to be used at a wide scale in burned areas in the Sierra, I think there's a lot more work to be done to develop parameters for retention areas. And I did put together some management recommendations. And just based on our results from these and also across some of our larger studies in burned areas, a lot of these need to be tested, but we hope they can be used for future planning of burned areas. So we recommend limiting herbicide use during the nesting season, if possible, goes from late April through mid-August, which I know conflicts with when you want to apply a lot of the herbicides. So that may be really difficult to work around, but it's, got to recommend it, then at least you don't disturb those nests in young of the year. We also recommend using a targeted approach with the smallest radius possible around conifers. There's some good research on this topic. And then leaving patches of intact shrubs within treatment units. You can also consider widening riparian buffers because you tend to get a higher diversity of shrubs in those areas. There's really no sweet spot for retaining shrub cover. Some species like fox sparrow like it really dense. They love like 90% shrub cover. And others like it a lot more sparse, with some openings and then higher species richness. So it's also worth evaluating the fire history of the watershed. Consider leaving a larger part of the fire area unmanaged if the watershed is largely undisturbed, which I think is something that is going to be moot here soon as more and more fires burn. And consider whether reforested areas have a high chance of conifer survival under future conditions and on southwest slopes, like at 4,000 feet, are they going to make it under different climate scenarios? And then I really liked hearing Rob York's presentation about experimenting with prescribed fire in plantations and maybe using more of like a ecological tool to manage shrub cover and to also restore an ecological process so we can keep trees on the ground. And with that, I would just like to thank El Dorado National Forest for funding and especially the Amador Ranger District and the ACCG for really supporting our work. And last but not least, our field technicians that had to hike through all those shrubs. And if I have time for any questions.
Yeah, I think we don't have time right now. So as folks think of questions, please put them in the Q&A so you can ask them during the discussion period. Okay, so we're going to move on to our next speaker, which is Lynn Schofield, who's with the Institute of Bird Populations. And she's going to be talking to us about California spotted owl management in post-fire landscapes. So Lynn, if you'll cue up your video and your presentation, that would be great. Perfect.
All right. We looking good?
Yeah, you are good to go.
All right. So I'm talking about a case study with spotted owl habitat use within a well-known mega fire. And, the thing about all of this wildlife stuff and examining it, it's a lot of case studies that you then have to look at from the big picture and determine, what really is the overall pattern, since every, fire is unique and every management regime is unique. So anyways, my little research project here is to use spotted owl survey data and remotely sensed imagery to first, assess the impact of the rim fire, which I'll give the little background on the fire. But the impact of the rim fire on spotted owl occupancy and distribution in Yosemite. Investigate how that fire altered the available habitat in Yosemite. Characterize the habitat that is being selected by the spotted owls after the fire, and how it compares to the habitat, on the whole. And then try to determine what habitat characteristics are the best predictors of territory locations, so we can strive to maintain those locations post-fire. So I'm not going to do probably a whole lot of background on this study system because I think people probably know a good deal about the California spotted owls that, if you're in this conference, but what's worth noting, California spotted owl, it's a unique subspecies of spotted owl primarily found in the Sierra Nevada. Although it is not like the northern spotted owl, federally listed as endangered, it has been declining across its range. They're considered a species of concern. They are managed for, and Forest Service and U.S. Fish and Wildlife, they both view and have identified officially that the changing fire regimes are probably a major, if not biggest, threat to the California spotted owl. And then the rim fire. Here's some aerial imagery of the rim fire. And this was, at the time in 2013 when it burned, it was the biggest fire in the Sierra's history. And now it's actually at 250,000 acres. Kind of dinky, given that the Dixie fire last year was well over 1 million acres. But 30% of the fire burned within Yosemite National Park. The fire kind of featured large areas of contiguous high severity burn, nothing like the King fire that was mentioned before, which has absolutely massive swaths of high severity, but there's still definitely very large homogeneous areas of high severity fire. But notably within Yosemite specifically, the fire tended to be a little bit more of a mosaic of mixed severities. And so that's why, it's kind of interesting to think about the Yosemite side of this fire. These mega fires do have major conservation concerns that we already know. Results from the King fire, they show that unburned habitat, the extinction probability and the occupancy probability, they're very normal in areas with lower amounts of severity. It's normal. And then once you get to high severity, you have an incredibly high extinction probability. So that's what was found in the King fire. And also occupancy of spotted owls in the rim fire as well on the Forest Service side was found to be that the owls tended to remain. So these are slightly different results. The King fire saw, a huge amount of spotted owls lost, whereas in the rim fire on the Forest Service side, they found spotted owls generally persisting and very little impact. But of course, how spotted owls respond to fires depends on the fire and depends on the management of the forest. So here's some nice little aerial images of, on the left, we have the national park side, just kind of a section of the fire there. And you can see the national park side, it's managed as the national park is, which is primarily for, recreation and or wildlife and habitat. Whereas the on the right, we have kind of an aerial imagery of what the National Forest side looks like, and it's land of many uses, so it's managed for many different things. So they're not directly comparable when you're trying to think about how a fire might impact the systems within. So one, we're curious how the owls are doing if they persisted within the rim fire on the Yosemite side, but also what characteristics of the habitat that spotted owls are choosing. Does the habitat that spotted owls choose, does it change after the fire, or do they try to adjust such that they get habitat similar to what they were in before? So anyways, quick overview of our methods. We conducted, and by we, I mean a lot of it is just generations of Yosemite field biologists, field techs. So relatively little of this data am I directly involved with. Initial intensive surveys were conducted between 2004 and 2006. So we have a very nice baseline of pre-fire spotted owl occupancy data. And there are 22 spotted owl territories with confirmed nesting and roosting identified before the rim fire. And observations of spotted owls were made, kind of regularly between 2007 and 2013 when the fire burned. And then between 2015 and 2017, after the rim fire burned, all the sites with previous owl observations and the surrounding areas were resurveyed annually to follow up on what happened to these territories. So the surveys, primarily, they were broadcast surveys. Initially, as they started, they would find where the territory center was historically. mark off a set of 8 points around that, broadcast to elicit spotted owl responses at those locations. And then if there is a response, techs would then try to find the bird. You know, so audio detections were always followed up with. And, you know, I love describing to people in the VAG, and then you feed them mice and you follow them. And people always find that very interesting to know, but the follow-up visits, you offer prey items to the owls once you find them. The owls with prey will be followed in hopes of locating a nest or roost site and determine breeding status, because how the owls handle the prey items is indicative of where they are in the nesting season. If they have a nest, they are likely to bring the mouse to a nest or chicks or a mate. If after 4 mice offered, they eat them all and do not offer it to someone else, you can assume that they're unlikely to be breeding early in the season. And so anyways, we revisited all of the territory centers that there had been any sort of observations in. If no nest or roost was found, we considered that to be a unknown. Otherwise, we considered it to be a observation. So anyways, here's what we ended up finding. Green dots here are where there are territories prior to the rim fire. Blue dots is where there were territories found after the rim fire. And you can see that there are lots of pre-fire territories and lots of post-fire territories, both before and after the fire. And in fact, here's the basic numbers, 22 territories pre-fire, as I mentioned before, and then 26 territories were identified after the rim fire across the entirety of the park. But of course, we're talking about the rim fire. So what did we find before and after the rim fire? 48% of the pre-fire territories that we found were within the fire boundary. 42% of the territories we found after the fire were within the fire boundary itself. So more or less, we're at parity, the same amount, you know, the same proportion of the existing owls were in and outside of the rim fire area, both before and after. So, you know, that indicates that the owls are still there and still persisting after the fire. Although an astute visual observer might notice that the 2 places where fire spotted owls were historically, that there are none close by anymore, is there, right in that big, dark, high severity burn area. But anyway, so spotted owls are present in the fire, great. What's the nesting status look like? And prior to the rim fire, of the 22 known territories, nesting was confirmed and observed, successful nesting specifically at a little over half of the territories. And similarly, successful nesting was observed at over half of the territories after the fire. And within the fire perimeter itself, you know, we see a similar ratio of birds that are found to be nesting. So 9 out of 13 of the birds nesting within the rim fire had confirmed successful nests. 8 out of 16 of the territories post-fire within the rim fire had successful nests. So we still have owls in the rim fire boundary. They're still clearly breeding. I will make the caveat that the studies were designed to identify territory centers and occupancy, and they're not directly comparable between the 2 time periods, the pre and post fire. So we cannot compare and make a statement that the breeding is more or less successful overall, other than we know that they are breeding, and they're breeding at decent numbers within the fire perimeter after the fire took place. So the owls are still in the fire boundary. They're still successful there. But most of the historical territory centers have moved to some extent. So the blue dots are the post-fire areas, and you can see that very few of those blue dots are actually on top of the historical territory center. They're nearby. And on average, territory centers moved about 2 kilometers. So that's a pretty good distance from their original nest tree. So the important question, are the owls moving to find certain habitat characteristics remaining within the fire perimeter? So our questions, did the owls move into locations with distinct habitat? How do their habitat choices compare with the landscape as a whole? Are they selecting landscape features that are relatively rare after the fire? Or are they selecting things that are still pretty representative of what's available? And how does their chosen pre and post fire habitat differ? So to do this, very brief on the analytical methods, we generated spatially random points that act as reference points to represent what the habitat as a whole is. So that's the black dots. They're randomly distributed within potential owl habitat. And we compared the occupied habitat characteristics with the unoccupied random locations. So it's a use versus availability test. And it is definitely true, without any question, that the overall availability of habitat has changed a lot in terms of greenness. So this is the NDVI, so metric of greenness. You can see within that rimfire perimeter, there's a lot less green cover. And in terms of canopy cover declined within the rimfire quite a bit. So anyways, where for all of these, we take a core area that's either the core area of the random point or it is centered around the nest or roost tree. We create a perimeter that's 121 hectare polygon, which is based on the size of a California Protected Activity Center on the Forest Service side. The Park Service does not have an equivalent designation. So we just picked a perimeter of approximately that side, and we calculated the average value for the landscape feature we're considering in these core areas. And what we considered specifically was the burn severity, the pre and post fire canopy cover, and the pre and post fire NDVI. And so here's our results, and I'll try not to be super long on this. So prior to the fire, as you might expect, the owls were selecting locations with a higher than average canopy cover and a higher NDVI relative to the overall habitat. So canopy cover is about 60% in the places occupied within the rimfire perimeter before the rimfire happened, whereas the average is closer to about 40. And then NDVI, the average NDVI where the owls were occupying prior to the fire, but within the perimeter, was above 0.6 and a bit below 0.6 in that landscape as a whole. Now, after the fire, though, what we find is that, surprisingly, the spotted owl territories were burned on average about the same amount as the fire area overall. So it actually, visually, it almost looks like the spotted owl territories had an average fire severity that's higher than the random sample, but the means are actually essentially the same. But so if you look at the landscape as a whole, the average fire severity is almost the same as the spotted owl territories in general. But although the owls seem to be living with the fire, they have their limits. The spotted owls, although within areas that had a sort of representative average burn severity, they had a threshold above which they could no longer tolerate a percentage of high burn severity. So after about 30% area burned at high severity within their core area, they would no longer be present. There were no spotted owl territories with an area greater than 30-something% high severity fire. So that's, very, very similar to what our colleagues working in the King of Fire found, that pyrodiversity is what the owls need, that after a certain threshold of high severity within their territory, they are no longer persisting. And then the other question about what the habitat characteristics they're looking for post-fire. What's pretty wild is what we found is the thing that really matters after the fire to the owls in the fire perimeter was the percent of area covered with canopy before the fire took place. So we're talking about owls and their territories after the fire took place are selecting territories where the canopy cover was high prior to the fire, although they're not specifically selecting areas where the canopy cover was high after the fire. So this seems like very weird, and it takes a little bit to say because we have before the fire, in the fire. But pretty much, unexpectedly, other than that proportion of high severity burn, the post-fire forest characteristics were not clearly related to presence. So what the forest was looking like in terms of canopy cover and NDVI after the fire were not different from the landscape as a whole. So, okay, pre-fire conditions was predicted of post-fire territory locations. Why in the world would that be? And it's either what creates suitable post-fire habitat isn't necessarily represented by the landscape features we're able to examine, or perhaps what creates favorable spotted owl habitat prior to the fire is also what creates the biodiversity that owls need after the fire, that somehow these two things are related. So to recap, because I feel like I get a little rambly with the pre and post in and out rimfire thing. Spotted owls remained within the rimfire boundary in Yosemite National Park. They continued nesting, and the occupancy and nesting really did not change. And that the biggest predictors of presence is the proportion of high severity burn and pre-fire canopy cover. So takeaways: spotted owls can tolerate disturbance, but are most tolerant when conditions are favorable to start with. So managing to maintain high quality spotted owl habitat now results in retaining spotted owls after the fire. And, as always, strive for a heterogeneous post-fire landscape, however possible. It is a credit to Yosemite's management to have created a location that has a relatively natural fire regime after a ton of work has taken place. And then it's important to remember, we still know very little about the long-term consequences of these fires. And what we see in Yosemite may not be at all true for the rest of California, since Yosemite is managed in a unique way. And then some big questions I have. So are the adult owls going to remain in the burned territories long-term, or are they going to slowly keep moving out? How well are the young owls doing after they leave the nest? The adults may be producing young just fine, but if those young are dying right away as they start to go into the world in these burned habitats, then it doesn't really matter if the adults are doing fine. Or will young birds, as they're looking for their own territories, will they move into recently burned fires? Or is it once the adults leave, they're gone? And then, how does the spatial scale of all of this, make a difference? And if anybody else has good ideas for questions to ask, I'd love to hear them. And then thanks to everybody who contributed to the project. Surveyors, people helping with imagery, the wonderful photographs in this, and yeah. Thanks, and probably no time for questions. I tried to go quick.
Yeah, we'll save those for the last panel session there. So still feel free to submit them at any time. We are now about to go into break, and we are a little over time, so you have a little shorter of a break, but we're going to come back at 10 till the hour, so at 1:50. So you have a 10-minute break, and we'll see you soon.
Hey, Jim, your camera and I think microphone are on, just FYI.
Okay.
All right, well, I hope we have most people back from the break. So we're gonna move on with our next talk of the afternoon. And so Jim Wilcox is with us from the Plumas Corporation, and he's gonna give us some background on meadow and restoration work in post-fire landscapes. So Jim, if you wanna queue up your presentation.
All right.
Okay.
Okay, can everybody hear me?
Yep, we can hear you and see the presentation, so you're ready to go.
Awesome. All right, well, Stacy said I'm Jim Wilcox at Plumas Corporation, and we didn't actually set out to make an assessment like we're going to share here. It began very organically as we began to get into projects that we had either participated in restoration over the years, or were developing restoration proposals and designs for upcoming projects. And we were somewhat surprised by some of the responses. And so it made us think about potentially looking more widely at the array of projects that had been implemented in the last 25 years in the in the Dixie Fire, as well as a suite of projects that were in the Windy Fire over the last 10 years, and to see if there was a commonality in some of the responses to the meadow to fire and fire to the meadow. So, let's see. So the Dixie Fire, well known, almost 1 million acres, over 2 national forests, 5 counties, and a national park, with a substantial amount of montane meadow in public and private ownership there. And again, probably 10% of those 20,000 acres have had some sort of restoration over the last quarter century. And then the Windy Fire burned shortly thereafter in the Sequoia National Forest, Tule River Reservation, and private lands in Tulare County. And there was a nexus of meadows that are being worked on or have been restored in the South Creek Basin on the Sequoia by Plumas Corporation and other partners. And that basin was wholly within the Windy Fire. So it gave us a pretty good data set. Begin looking at, was there a commonality to the first observations we were seeing as we were able to access post-fire? And hang on. What we were beginning to see was that there seemed to be a trend between meadows that were hydrologically functional and those that were hydrologically degraded. And so we went and visited at least 26, it's actually more now, meadows between the two fires that either never degraded and were hydrologically functional or had some sort of restoration to restore function, and those that were degraded and do not have hydrologic function at the time of the fire. And I think it's important also to note that meadows have an outsized role in landscape carbon stocks, a fair bit of recent research. So that's sort of rolled into this assessment, and something to be thinking about as you look at the visuals as we go through this. So loss of hydrologic function in meadow is generally related to channels widening or deepening, which reduces or eliminates overbank flooding, reduces the frequency and duration of meadow soil saturation, particularly in the root zone of the meadow plants. That change in frequency and duration then induces a composition change to the vegetative communities and their habitat values. During annual or long or multi-year drought conditions, plants in those meadows have extremely low moisture levels, and as well as the soils, and appear to be susceptible to severe burning conditions based on what we'll see through the course of this. So these are just examples of hydrologically degraded meadows, from somewhat incised on the upper right to severely incised on the upper left. And the lower picture with the star just happens to represent the same picture on the next slide. So these are hydrologically functional meadows. This is on the upper left is Yellow Creek in Humbug Valley, or Tasman Koyam, as it's known by the Meadow. Double Bunk Meadow on the right, excuse me, is a meadow that's never degraded. And then Cottonwood Creek in Big Flat was a restoration project done 27 years ago. So the commonality here is that even at somewhat lower flows, water level in the channel and in the adjoining soil is high. It's in the root zone of the plant. In high water, these channels can spill quickly and spread out over the floodplain, infiltrate, filter sediments, and flows out of the watershed, and allow a long residence time for water to sit on the soil and become absorbed for later use by plants or released back to the channel. So as we were watching or observing, assessing these meadows, we were seeing similar kind of a stratification as you would in the forest. You have meadows that did not carry fire. You had thatch burn, which kind of like an underburn, basically just skittering through the organic layer on the surface. A plant burn where most of the surface material of the plants burned, but the roots and the root collar appear to be mostly sound. And then root burn, where the fire basically followed the roots all the way into the soil and completely consumed the plant. And almost all the meadows here had high severity fire hit the meadow on one or more sides. So they were subjected to some pretty severe conditions. These are just some examples of the different severities. The upper left is functional area on Yellow Creek in Humbug Valley. We see the thatch burn through, however, the sedges have already resprouted within several weeks, and the little, if any, of the functional attributes of that meadow have changed. The upper right is a tributary meadow to Yellow Creek, farther upstream, and an area where you had severe root burn in the foreground, and basically left just bare soil, no roots at all. And that picture was taken this spring. There's been no regeneration or germination of new plants. The part of the meadow in the background is more influenced by fens, so it has slightly higher moisture content, and so more of a thatch plant burn, and it is recovering. The lower right is another section of Yellow Creek that's not functional, is where fire moved through, pretty well consumed most of the top growth, most of the willows. You see the surrounding forest also. And then Double Bunk Meadow on the lower left, down the Sequoia National Forest. Again, this is an area where with just several feet of incisement, the fire was able to burn hot enough to consume the plants, and even hot enough to burn the willows so they're not resprouting. And here's some more examples of more of a thatch burn. Horse Meadow and the Sequoia on the left, and Long Meadow and the Sequoia on the right, on the upper right. And it should be noted on the upper right, the Long Meadow was in a large managed fire, late season fire in 2016, as well as the background hill slope. And even though the windy fire moved through here, it left little in the way of long-term effect on the meadow or the previously burned hill slope. And then the lower right and left pictures are Last Chance Creek on the eastern portion of the Dixie fire that did not burn. The fire moved across, jumped the meadows because there wasn't anybody there to get spots, but the meadow itself didn't burn. And this is Thompson Valley again, sort of looking at a degraded meadow. This is where the vegetation had converted mostly to sagebrush. And upper right or upper left is pre-project, upper right post-fire, and another view of the meadow post-fire in the middle and the bottom. Just as a note, we will be implementing restoration work on this project starting Monday. And here's some more. Again, these are kind of like pre-project condition, post-project condition, post-fire. So here's parts of Yellow Creek and Humbug Valley, pre-fire on the upper left, post-fire upper right from the same photo point, or post-project, and then post-fire it's the bottom. You can see some of the willows are scorched. You can see over here where fire burned through the thatch, but the sedges are already recovering. Another portion of Humbug Valley where restoration hasn't had an effect. You can see that the valley has been highly modified by ditches for irrigation, drainage, and fire got into the plants there. And this was taken this spring. there's a wide area of pretty hard plant burn, and those lighter areas are root burn. You drive out there any day this summer, and there's dust blowing in the wind from those plant burn area or root burn areas. Well, this is a little close up of what we saw before of a root burn. This is a YCO2 meadow. The pre-project condition is upper left. You can see the vegetative community was there, but it was thinning out and not vigorous because of a lack of water, the dewatering of the incised channel, and then a repeat of the earlier picture, and then a close-up. So that's your residual soils with, obviously redoxymorphic color to it. So it was once quite wet, and now it has essentially no organics. And it will be interesting to see how the recovery goes. This is actually a project that after the fire and after the October storm, we actually implemented this project in November of last year. However, we did not attempt to do anything with the root burn zone. Another pre-project, post-project, post-fire, red clover, McReynolds. This is again on the east side of the Dixie fire, and pre-project on the upper left, post-project upper right, post-fire in the middle and the bottom. And you can see the fire moved through, but did not really burn the meadow vegetation much at all. And here's a area of that same zone. The Dixie fire was being pushed by 40-mile-an-hour gusts when it moved through this area one afternoon. So it was burning pretty hot. Farther downstream, north on Red Clover, another project on the Plumas National Forest. Pre-project, post-project, post-fire. And I think the key elements here, again, are the resiliency of these landscapes. This was the first project that my colleagues visited right after the fire on the upper left, expecting to see the meadow completely burned, given the severity of the fire, and finding that essentially the fire stopped at the meadow, other than skittering here and there in a few places. It did not burn across the meadow. And despite the fact that it was bone dry at the time of the fire, there's enough residual moisture, appeared to be enough residual moisture in the soil and the plant material to retard or resist burning. And so that's really kind of one of the key issues here, is having the ability of these landscapes to hang on to some moisture, even in extreme drought conditions, and to be able to resist the effects of these fires. This is an aerial photo of the same meadow. The fire came from the right-hand side and hit the meadow, and actually had to kind of stop, move around, or jump over and begin again on the opposite side. So the general trends that we are trying to, we think are being evident here, are that the hydrologically functional meadows can sustain thatch burn with scattered plant burn, or do not carry fire. And they maintain their habitat values and their soil carbon stocks, because they're most of the carbon in the meadows is in the soil. And they're a place of refugia post-fire immediately, again, because they haven't been completely altered, while hydrologically non-functional meadows sustained widespread plant and root burn, and basically did not impede the fire spread, and in many cases lost a significant portion of the habitat. And even if we didn't lose the roots, they're still passively emitting soil carbon. So the idea of having functional meadows that are resilient, resistant to fire and disrupt fuel continuities from upland to upland. And they may be able to provide an anchor point to initiate suppression actions, save a little line building, maybe save a little bulldozer work in a meadow. It's happened more than a few times. On a number of those projects, you notice a lot of open water. They have been used for helicopter dipping and also for pumping the hose lays. And while a meadow in itself probably won't stop high intensity wind driven fronts without people on the ground, they're still a good point to plan for your suppression. Now, these are obviously fairly gross representations, and our hope is that this will help spur some more investigation and research into some of the points that appear to be evident here. And because I mean, Plumas Corporation, we're implementers. We don't do a lot of research, so we would really value the research community's involvement in further investigating what it looks like, the trends we've seen here. And for that, I thank you. If we have questions now, or we'll wait till the panel.
Excellent. Thank you so much. We have probably a few seconds, but I think we'll probably save questions for the panel. I saw a couple pop up, so some good ones. So we'll address them momentarily. So stay tuned, and please, everyone, add your questions to the Q&A for the discussion that will be right after our next speaker. So we'll move on to Karen Pope, who's with the Pacific Southwest Research Station, and she's going to be talking about some of our aquatic resources and monitoring them in post-fire landscapes. So Karen, if you want to turn on your camera and share your presentation.
Great.
Okay, you're looking good. I can see your presentation and you came through great.
Okay, great. All right, so I'm going to be talking about monitoring aquatic wildlife in post-fire landscapes. And I want to acknowledge co-authors, Karen Goldberg and Jonah Piovia-Scott from Washington State University, Greta Wengert from Integral Ecology Research Center, and Adam Cummings, who also works with me at the Pacific Southwest Research Station. And this project received funding through NIFWIF and also the Forest Service. And I also want to acknowledge Jeff Mabe from the El Dorado, who was just totally the keystone of this project. And I want to state that we came to the Power Fire research late in the game. This project was done in 2020 and 2021, which you can imagine were pretty tough years for being out in the field collecting data. Let's see. So first, I just want to talk about what it means to do post-fire aquatic monitoring, and a few things become very clear. One is that there's just more water available. So looking at maps of where water isn't necessarily going to find all the aquatic habitats that we should be looking at. Two, that in high burn areas, it's almost great. You can see where you're going and where you should be going. They're more visible and more accessible. And then, of course, wildfire provides a natural experiment. We have areas with high burn, areas with low burn, and areas with no burn. And so we can learn different things about the different habitat conditions and how the aquatic species respond to them, such as what Jim was talking about, different severity. And then it becomes opportunities to go from there. Okay, now we have this reset. Can we add restoration to improve conditions in these aquatic landscapes? Real quick, some of the methods that we use for looking at aquatic wildlife, and these would be amphibians, fishes, and then invertebrates primarily. And so electroshocking is one technique that is often used for fish surveys in larger rivers and lakes. Actually not really some lakes, but sometimes you can gain great information about abundance and size, structure, body condition. And you can get the animals in hand, you can mark them and release them. It is labor intensive. You have a shocker and catchers, and then it's also not appropriate in some habitat conditions, such as real shallow headwater streams, or when a lot of rare species are potentially present. Visual encounter surveys, just as they sound, it's walking the shallow section of edge of streams or ponds and lakes, and using your hands and your eyes to find critters. It's highly effective for animals that you can see, and it's cheap, and you just walk fairly quickly. And however, if there's rare species, you may not see them. So we get presence data, but we may not get absence data. So we don't know if they're not there or we just missed them. And that brings in environmental DNA, which is highly sensitive. So if the animal's there, it's going to detect it. It's highly specific. You know which species. Like, I saw a frog jump in the water, but I never saw it again. The eDNA sampling allows you to identify which species it is. It's also not invasive. You're just sampling water. However, you get no information about the size, structure of the animals that are there or the condition, because you're not seeing them and you're not having them in hand. And then there's spatial and temporal issues, like if you go into a system and a species like Yosemite toad that comes in and then gets out, you may miss it because not that it wasn't there, but that it's already in the terrestrial landscape. Or spatially, you can get a positive sample in a stream, but you're not sure where that DNA came from. So just real quick, probably eDNA is the least well-known sampling. So I'll just go through that real quick. So the idea is basically that everybody, all living things are shedding their DNA, and in water we can collect that DNA. And this technique, usually it's people collecting in bottles and then pumping through a filter. There's Slick, Smith and Root backpack sampler that's similar to their electroshocker, but they switched it to a vacuum, and it sucks up the water and pushes it through the filters. And so you can get, this is a duplicate sampling technique. And so you can get a lot of volume in a short amount of time, process it, and replicate the DNA and compare it to your DNA of your target taxa. Because there's been a ton of research on eDNA, but mostly in streams and lakes and ponds, we wanted to make sure it could work in more complex landscapes such as meadows and complex floodplains, and so did a study to see if it worked. So we went to places where we knew we had animals, they were well studied, and we knew where they were and sampled in those locations. And basically to see, do we get positives when we know there should be positives? And then within a site, do we get negatives, even if in areas where there's non-animals, even if there's positives over here? So can we just bring in the sampling system and go from positive to negative to positive to negative? And the answer was yes. And so we can, to some degree, tell where the animals are within a complex meadow system using eDNA. And of course, visual surveys, but in these complex landscapes, visual surveys can get very tough. And what we found was that the eDNA was more effective than our visual samplers in general, but both did very well. And so we felt confident that joining eDNA with visual was a great way to get really accurate sampling. And so that's what we applied to the PowerFire landscape. And the goal that was handed to us by the forest and that we came up with them was to determine the occurrence patterns for aquatic species within areas affected by the PowerFire. And a side goal of ours was to see, can we apply this sampling technique on this larger landscape? The target species were Sierra Nevada yellow-legged frog, foothill yellow-legged frog, rainbow trout, American bullfrog, brook trout, and signal crayfish. The two amphibians are both rare. And then rainbow trout is a recreational fish. And then the three others are invasive species, non-native species. Brook trout, of course, are introduced for fishing, have been. I don't think that's occurring very much anymore. So just to dig a little deeper into the two frog species, Sierra Nevada yellow-legged frog is listed as endangered federally and state, and foothill is state listed as endangered in this clade that encompasses the PowerFire. In some areas it's not listed, and in some areas it's threatened. And basically that goes north to south. So in the north it's not listed, and then in the south it's endangered. And one thing to note here is the Sierra Nevada yellow-legged frog is high elevation and is a lentic breeder. It breeds in still water conditions, whereas the foothill yellow-legged frog is our river breeder, stream breeder, and occurs in those mid to lower elevations all the way to coastal environments. In our study area, we knew of one breeding site, Dufresne Pond, in the PowerFire nexus, and then there were sightings of frogs elsewhere, but a question was, where are these frogs coming from? What are they doing here? Is there an unknown breeding location, or are they just dispersers coming down from higher elevation habitats? And then the foothill yellow-legged frog is known from the McCollumee River and some tributaries, but just outside of the PowerFire footprint. And so the question is, does it move up into those tributary streams that occurred on the fire footprint? So one of the first things we did was look at the documented occurrence of these species within the PowerFire. So the sort of tan color is PowerFire, and the yellow stars are foothill yellow-legged frog, and the pink stars are Sierra Nevada yellow-legged frog. And so you can see in the footprint, and so you kind of see that the two species occur right on the edges of the fire footprint. And so what are they doing within the fire footprint at this time? So getting into our design, we really just focused in on where we knew past occurrence had been. And so we looked at these areas and set up a sampling design to work our way downstream from those sites and try to identify what types of habitats these species were using. And then for the foothill yellow-legged frog, we went to the tributary streams, realized how crazy steep and dense the vegetation was along those sites, and so dropped our visual encounter surveys altogether in those environments for the safety of the crew, and focus on eDNA in the perennial streams. We also partnered with swamp surveys that give stream conditions, so use benthic macroinvertebrates and stream habitat to relate to a California database of wadable streams, and we can get an idea of the condition of the streams relative to reference streams in California. Jumping into results, don't worry about this other than we found Ranicierae, the Sierra Nevada yellow-legged frog, exactly where it was known to occur and not anywhere else. The foothill yellow-legged frog we did find in one of the tributary streams, which to me suggests that it could be occurring in any of the tributary streams on the fire footprint. Rainbow trout was our most commonly found, and in some cases really high densities. eDNA doesn't, we don't really trust it with abundance, but there's a pretty strong correlation that when you get really a ton of DNA in your sample, that it's a good sign that there were a lot of them. And interestingly, we didn't get any brook trout or bullfrogs, which was great. And then signal crayfish we did find, but only close to the reservoirs. And so just zooming in on Ranicierae, basically Dufresne Pond was where we found them with eDNA. We saw, we had a couple visual sightings in intermittent streams, so we weren't collecting eDNA at that time down just around the pond. But in our samples looking elsewhere, we did not find any. And so what that tells us is those, we think, our hypothesis is that the occurrences of random sightings of individual frogs in Coal Creek and such were those dispersers moving through, and there probably isn't another breeding population in these lower elevation streams. And then again, foothill yellow-legged frog was found in one of the wetter tributary streams. So the results for power fire surveys were Dufresne Pond is an important population and should be treated as such. The lower elevation streams occurrences probably rare, random sightings, random movers. Foothill yellow-legged frogs probably do occur in the area, but maybe just moving up during summer times or high flows in the main river. Rainbow trout are doing well and are fairly widespread, and the non-native bullfrogs and brook trout are not present. Crayfish, signal crayfish, are a species to watch because they can pretty quickly expand their range through the streams, and they're pretty detrimental to native amphibians and invertebrates. Stream condition varied and was not related to fire severity. We didn't see it. It was related to the local conditions in that reach, and varied from pretty poor to right in there with reference streams. And I just want to jump to sort of move on from both the aquatic wildlife and stuff that Jim was talking about, and really try to look at the restoration potential in these post-fire landscapes. and not focusing on those giant meadows that Jim was looking at, but some of the more small headwater meadows and streams that burn pretty hot because there's a right in there with the forest. And here's an example of a small meadow that you can see just the fire just jumped right through. But if you look closely, you can see here there is an incised channel through this meadow. And if you imagine that the meadow was larger, so this dog-haired conifer here, there really isn't a slope change. And so this may be that because of the incision and the drainage of this meadow over the past 150 years has changed to forest and may have been much more expansive in the past. And if we believe that to be true, then there's an opportunity to expand some of these meadow and floodplain habitats to make them more resilient to fire. And post-fire landscapes are great for showing that, those opportunities. And so we kept running into sites like this and said, okay, well, can we do some modeling to see what that potential could be? And we use machine learning, and we use the existing meadow layer of over 18,000 meadows in the Sierra Nevada, and trained a model to find those same geomorphic characteristics and climactic characteristics and flood accumulation characteristics while ignoring vegetation characteristics. So those vegetative characteristics that define meadows, we said, let's not look at those, because we acknowledge that some of those meadows may have turned to forest. We applied the model across 60 HOC10 watersheds in the Sierra Nevada, and found that basically, so the red perimeter is the hand digitized existing meadow layer, and the green is our model output. So basically what our model is saying is we potentially, so down here, there's a meadow without any polygons, and then some just join multiple polygons into one much bigger meadow. And so one rationale for not including meadow systems in a fire resilience package is that they are so rare on the landscape. 1% to 6% of the watershed of the landscape in the Sierra Nevada is meadow habitat. And we found that to be exactly true. So on the x-axis is our hand digitized of those 60 HOC10 watersheds, and basically from close to 0% to 6+%, the landscape was meadow. And then our model predicting potential meadow habitat basically times those by about 3.5. And so we now are closer to 10 to 25% of the landscape. And so when we start getting up there to 10 to 25% of the landscape, meadows and low gradient floodplain habitats have a much higher potential for affecting fire behavior in the future. So this GIF shows basically a forested landscape that we just sort of run through LiDAR model output and the baseline conditions right now. Here's the meadow polygons, that hand digitized meadow polygons. There's the LiDAR showing what's underneath them, and there's our model output. And so you can really see in that LiDAR section that there is a high potential to expand if we just get rid of this incised channel here, spread water over that floodplain. There's a high potential for greatly increasing the size of the meadows and our fuel break. And down here in this lower meadow, in this lower area, there is no existing meadow habitat, but the LiDAR clearly shows that there could be, and our model says there should be. And you can see at the foot of the meadow, the base at the bottom part of the meadow, there's a pretty severely cut out incision, and it may be associated with that upper meadow draining down through it. So what does burn have to do with it? It's more, you can see it. You can actually see what the potential because the trees are burned. We can also make use of the known expected pulse of sediment that's going to come off from those exposed hill slopes to fill our incised channels. And from there, you can also make use of the slash in the wood that's available post-fire, and then from there, take that opportunity to expand and sustain future fuel breaks. I threw this in, and then Jim gave his presentation, and so it really is redundant, but this is Tasmamcoyam downstream from where Jim was talking about, and this little side channel, Miller Ravine, and the map is NDVI. So basically the more blue is the more wet and moist the vegetation is. And so this is in October when things are winding down and pretty dry. So Big Spring is a spring habitat. So that's this dark blue area next to the circle. And then in 2020, a team went in and did it was a team that used tribal volunteers and did a build in the upper part of the tributary, and then really spread flows and increase the number of confluences down to the main stem. And so did it in October 2020, and then in 2021, you can see that area is one of the only increased wet blue areas post fire. So so what that means is you can do kind of minor things in these landscapes to really re-wet surfaces and create fuel breaks. So it's an effective, cheap way to create wetted landscapes that are resistant to fuel, to burns. So conclusions from those two are pairing eDNA and visual encounter surveys are highly effective for sampling aquatic wildlife in post-wildfire headwater stream environments. We did it quickly. I feel like we have accurate results, and we're confident in those results. And then also the opportunities for restoration in post-fire landscapes. And I see you, so I'll stop. Yeah, so capturing sediment, increasing fuel breaks, and improving conditions. So with that, I'll stop sharing.
Yeah, excellent. Thank you so much. That was extremely interesting. I think we probably have some questions in the chat and the Q&A to address. So I think now, since we're in the discussion period, I will ask everybody from the afternoon presentations to turn your cameras back on so that we can see you. And then Stacy, I'll pass it over to you to start our Q&A period.
Yeah, thanks so much. So there's a few questions from various different places. So I'm just gonna, if they were addressed, I'll address it to somebody. So the first one is for Karen, which was, how was the number calculated for a species where eDNA only records presence or absence?
Yeah, so that was the amount of basically eDNA material that was replicated within the sample. And so we, as part of our previous study that I mentioned, we correlated that that number of the replicate number with actual density of animals in these areas, and found that it was pretty correlated. I think, you know, it was R squared of 0.8, something like that. So, so basically when you get a big count, it means it's probably pretty common and you're getting a lot of DNA.
Great, thanks. That makes sense. We're going to jump to one from the Q&A now. So this one's for you, Alyssa, which is, how do the number of birds and diversity of them compare between prior to the fire, when the forest was undisturbed, and with your data after the fire?
Yeah, I don't have data from Power Fire before and after the burn specifically, but we have quite a bit of data from across the Sierra, and there's been a lot of research on this from other folks in Western conifer forests. And what you find before and after the fire depends a lot on burn severity. You know, like if it was a low severity or even moderate severity fire, you will see some of the same birds stick around, and you even increase your diversity because you have more like habitat heterogeneity. You know, you've got the shrubby patches coming up, and then you have the patches of dead trees bringing the woodpeckers. But when you have, you know, high severity fire, from undisturbed to high severity, your bird community changes quite a bit. And you get more of the open habitat species, and then the ones that are more reliant on snags. So, and then also that depends on time since fire. So it's those two different variables that interact. And I've got lots of, you know, I can share lots of papers if you want to reach out, but I'll keep it brief.
That's great. Thanks so much. So I also want to invite people, you know, I know it is getting later in the afternoon, but if you have any questions for anyone, feel free to put them in the Q&A and we will kind of prioritize those. But I know we had a couple of questions. Chuck, I'm going to call on you, you know, and feel free to just unmute yourself and ask your questions directly. So it's a little bit more of a conversation.
Yeah, and I had a couple that ended up being related both for Jim and Karen. I think Karen, you already answered my first question, which was to Jim about possibly reclaiming areas around the meadows. You know, how much do we expect meadow and wetlands to expand now that the fires come through and removed all the straws and the conifers that encroached on them? And I think I got that answer from you, Karen. I'm assuming, Jim, you see a potential there too. And then related to that, on Karen, on your talk about treating the insides channels to bring those meadows back. I was just curious, beyond just some of the lighter hand treatments you were talking about, how you would see getting those channels back, because I know ponding water has been a issue for exotic species like bullfrogs, and I'm not sure how we would do that without taking that risk on. I was just curious if you had a take on that. And then one more, and I'll throw it all, it's all together, it's all related. Anybody have any idea how much of that area, like Karen, I guess this would be mostly directed to you, might have carried aspen? Because I think a lot of those areas probably had aspen in the past, and maybe doesn't now. And if there's any way we can figure that out, because that would probably might be a good place to do some reintroductions. I've had fairly good luck starting aspen on my own. And anyways, all three of those are related to that after fire, meadow, wetland area, and expansion potential that we have.
Yeah, no, I think that, you know, I really appreciated the model work that Karen's done, because it's spot on, whether it's conifers or sagebrush. We are often characterizing the meadows in the Sierras as only those that still have meadow characteristics, and we are losing a lot of old meadow habitat or potential habitat. And a fire comes through, and rather than waiting maybe for a restoration project to gradually drown out a encroaching lodgepole or other conifers, it takes it all on one fell swoop, provides a lot of large wood right there. And if the incision isn't too severe, and you know, like Karen said, you can get a lot of structural input right away, and use the materials from the disturbed basin to start rebuilding things. And again, you are going to have more water available at the Meadow Hill Slope interface because there are fewer straws, and that in turn will help keep encroaching woody species out and allow the meadow to potentially reach its full extent, taking advantage of the disturbed conditions. And Chuck, in terms of the aspen, you know, we haven't had the greatest luck ourselves trying to incorporate aspen into restoration. It seems like they do have some pernicketiness about where they like to be, soil type, moisture conditions, and but you know, I think it's great. But we're working more now in meadows that actually have some aspen, and it'll be interesting to see how it responds. If it responds maybe similarly to black cottonwood. Anyway, that's kind of my take on the tripartite question.
I'll jump in and say, yes, I agree with what Jim just said. And then also I agree there's a post-fire opportunity for aspen recovery. And I would love to see even frankly willow recovery, because I've seen a lot of degraded meadows where we have alder thickets, and it seems like there's some evidence that livestock prefer willow over the alder, and so you get these pretty dense alder thickets around streams, and when you're working in those, they're really hard, but when they burn, the alder burns, and so it'd be great to work in those systems and see what we can do to get willow and aspen and meadow vegetation instead of these monocultures of alder.
I'll open it up again. Oh yeah, go ahead, Helen.
Okay, now I'm unmuted. That got me thinking about these, you know, all these smaller stringer meadows that have encroached over time, and that Karen is, you know, showing on that modeling, how important those have been in places where great gray owls are still, you know, still have a stronghold, like in the Yosemite area. They use that for foraging, that edge, meadow edge. And so those stringer meadows really are valuable habitat for them. And it is something that, you know, you think about over time, if we've lost a lot of that type of habitat, just, you know, through lack of fire on the landscape where they've become encroached, as well as the degradation of the stream channel so that they're drying. It's just something to think about too, that we could see some looking at sort of the great gray owl behavior in some of those places that have burned, and if they're reoccupying areas like that, or you know, thinking about creating habitat for them by reclaiming some of those stringer meadows.
Cool, let's talk, Helen.
Love the networking. It's great. I think we probably have time for maybe one more question before we wrap up. Anyone from the panel or anyone want to put something in the chat or the Q&A? Or Becky, maybe you got one?
I do, most certainly. And I will say that I think we can take a few more minutes, because I don't think it will take me 10 minutes to wrap up. I can shorten that a bit because I feel like we don't have quite as much discussion time in the afternoon. So I just want to make sure all the questions get answered. So I'm going to defer to others to answer their questions right now.
So I had a quick question for like Jim or Karen. I was looking at the pictures, Jim, you had of the meadows where the root mat got burned really. Do some big revegetation efforts in those areas, or is it more like fixing the hydrology is a higher priority, and then the native vegetation like the sedges and the herbaceous layer will come back on their own?
Well, that's a good question, and it's one we're actively kind of staffing with the forest and the botanists there, whether we want to. I mean, I think I think there's a strong interest in doing some seeding this fall just before snow comes, and to try to jumpstart propagules there. I mean, if the meadow were to flood some, it would bring in propagules, and it might do it on its own. But my concern is it might flood too much, and we'll lose a lot of soil before we get the right conditions to really get the vegetative armor layer on it again. So personally, I haven't dealt with this before, so it's kind of new for us, and it's something that we'll continue to track with everything we've been observing. We're going to continue to follow, and we may have some follow up in a year or two of kind of how things did after our thumbnail assessment.
Just really quick, Karen, I just was wondering if your potential meadow layer covers the Caldor Fire area, and if that's been supplied to the forest team. I see Becky smiling, so she's probably already knows the answer to this.
Yeah, we have the Caldor Fire, and I think Eric Nisita did a little assessment too, and so we looked at his assessment and our assessment and sort of put it all together. And you know, in some cases his matches ours perfectly, and in others we expand beyond that. So yes, and I can give it to whoever wants it. We've provided it to Pat Manley to disperse as needed. But we can talk you through it and run it with you and give it to you anytime.
Great, thanks.
Yeah, I'll just tag on. Yeah, I think there was already some movement from a number of different entities in assessing Caldor meadows. So Karen, I really appreciate your predictive model, and I think it will be really extremely useful, not just in Caldor, but forest-wide, just to start us thinking about, you know, because this has made me start to think about how important it is to identify maybe where there's the potential for meadows before a fire, so that we can, you know, like Jim mentioned, you know, get in there and implement and restore those so that they're fully functioning before we have a Caldor fire come in. So I kind of see it as, you know, twofold use there. But yeah, I think there's some movement in Caldor, and I think it will be interesting. And one of the questions I had was that, you know, has there been any field recon on those predicted meadows?
Yeah, just some, and we've been really struggling with, you know, what that looks like when you're talking about not habitats that are no longer meadows. And so our approach for the study, for doing a manuscript for validation, is high resolution LiDAR. And so we're going in and asking, is there a source of degradation, or, you know, that's visible, that would lead us to believe it had been a meadow and is not any longer. But we talked about doing soil sampling. We're doing this model is, you know, no added cost. We're not funded to do it. We just decided we needed to do it. So doing a big validation, we want to work with the forests and say, here's our model, please tell us what you find, and use it to self-validate as people go out there and assess these habitats.
I think we might be able to get even more traction for this type of work if you tie it into the strategic fuels fire plan for the pods. I mean, because meadows and green areas like that are important anchor points. So I think that would be a way to maybe get some more funding and interest in it. I know we tend to focus, some of us, on the wetlands and the restoration factor, but I think if we tied it into that, I think we get some real good synergy with the project.
Yeah, it's that it hasn't been the area of the Forest Service that I've worked with a lot, and so it's kind of hard to get your foot in the door. But that's exactly what we're trying to. We realize the Forest Service is all about fire and terrestrial activities right now, and so incorporating. And I think, you know, I'm willing to just say, you know, as the opportunity arises, we're not asking for a ton of work. It's just really, you know, throwing some wood in, anchoring it well. There's some experience needed, but you know, we'll train trail crews or fuels crews, and it's not going to be a huge lift beyond what's already happening on the landscape. So I think the potential to work across a larger landscape is there, and we just have to get that enthusiasm and training out there.
Yeah, I want to just kind of weigh in. You saw some of the pictures of Double Bunk Meadow and the Windy Fire, and once we saw how vulnerable that meadow was, because it's actually fairly steep gradient. We mentioned it to some of the forest staff, and they immediately started had fire crews out there dropping wood from the forest into the meadow. Just something, and again, like Karen says, easily mobilized soils. Just a little bit of rain we had last year, we're moving soil around, so getting some structure in there. Just trying to slow the velocities, drop material until you can do something even a little bit more sophisticated than you know, to help these meadows hold in place and not unravel on us while we're waiting or trying to figure out how to put in a Cadillac model or something.
All right, well, I think now we should start to wrap up. So Stacy, I'm assuming you have a few things that you want to mention from the CFSC side. So maybe you go ahead and then I can close us out.
Okay. So yeah, just as a follow-up, this was recorded. It's a long recording, so it's going to take me a little bit to edit out like the breaks and that sort of thing, but I'll let everyone know when that recording is available. If there's any follow-up materials, I'll put an email together with that, you know, like some of the papers and stuff that we were talked about today, and anything else from the presenters. And then as you close this, you're going to be brought to a super short webinar evaluation. It takes about 5 minutes, just helps us with our funders to report back that these are still being used and are useful. And if the format and all the organization stuff worked, like I said, it's pretty short. It's a couple multiple choice questions, and we really appreciate you taking that. And of course, at the bottom of that as well, there is an option to sign up for the newsletter, which is a monthly thing I send out, just letting you know about webinars, new publications from the consortium, other outside and internal events coming up. So look for that as well. I think that's all I had. So go ahead, Becky, wrap us up.
All right, excellent, thank you. And we really appreciate your help in coordinating both the webinar today and the field tour tomorrow. So I just want to also say a couple of other thank yous. Thanks to all the speakers today. I think this has been really great. I feel like we never have enough time. And, you know, sadly, when we meet via virtual format, we don't have those amazing discussions during our break periods. You know, you just go talk to yourself in the corner or reply to emails. But hopefully some of you will be joining us tomorrow for the field tour, and we can continue these discussions. But I really appreciate all the speakers. And I also just want to thank the ACCG Monitoring Work Group and SOFAR Landscape Design Team. I think this was sort of born from a discussion between these two groups on, hey, we should work together on starting to think about post-fire restoration and planning a field tour to think about what worked in the Power Fire and how we could apply it to the Caldor Fire. So I will just say that the Power Fire field tour is tomorrow. So if anybody has any last lingering questions, please reach out to me. I'll be happy to answer them. And then stay tuned. In the fall, we will be scheduling a field tour in the Caldor Fire that will be very focused on post-fire restoration and really, you know, continuing the discussion we're having today and tomorrow into thinking about sort of short-term and long-term goals within that landscape. I think that's everything that I wanted to say. So we'll get you out of here 3 minutes early. So everybody have a great afternoon. And yep, please look for the recording for those of you that weren't able to be here today or to share with others that couldn't make it. So thank you, everyone. Virtual clap. Good job,
Thanks so
everybody.
much.